Okay, cool. So just so everybody knows, we do have limited seats. So this is the perfect example of Meetup. We had 49 people sign up. I was like, how am I going to fit them in this room? And it's like, well, very easily. So if you can't come, that's cool. I don't care. Just please cancel your RSVP so we know what's going on. And we're normally going to try to start about 6. So stream horizontally. If it doesn't, let's see here. It's not made for kids. Go. Oops. There you go. If it's not on social media, it doesn't happen in the real world. So anyhow, my viewers are like, "Are you gonna stream it?" I was like, "Oh well, maybe I'll make a couple of bucks off of it." Okay, so obnoxious question then. So a lot of people actually know who I am. So most people know me to some degree. Okay, yep. So basically I've been doing technology since 1996. I started doing technology education back in 2009 before you could say like YouTube, because nobody even knew what YouTube was. So what I'm trying to do here is essentially empower people with technology education. So in the 16 years I've been doing online tech education, I got about 1.1 million. Yep, come on in. Is it locked? There we go. I've got 1.1 million subscribers on YouTube, and which is what it is. The amazing part is how many people around the world I've touched. The stories are just whack. I was in the Roman Forum in Italy, like getting over a hangover. And literally, there was like these 2 walls, like if you ever go to these ancient places, and one wall is very important and one wall doesn't matter. So I'm trying to figure out which one mattered. And literally, this Pakistani couple from Pakistan walk up to me and go, "Oh my God, you're Eli the computer guy." And so as I'm getting over a hangover in the burning sun of Italy, I'm getting a picture taken with these folks. I ran into a guy in Asheville late one night. I was really tired. I want to go home. My wife wanted another drink. And I'm just in the bar, and like a black guy walks up to me. He's like, "Oh my God." He has like, "Ah." And I'm like, yeah, because a lot of people have said this. And he's like, "No, you don't understand." And I'm like, what don't I understand? He said, "Look, I'm from Africa. I'm from Africa. The village I had did not have internet connection. I used to walk to a village to download your videos in order to take them back to my village and watch you." And now he was in a university program in Cincinnati. And so like that's the power I've seen on being able to do the YouTube videos and things. And so my question is basically, can we bring kind of like the YouTube experience into the physical world? Just the way somebody in India or Pakistan or Africa can download a video and simply watch it and empower themselves, can we create a kind of a physical environment that allows people to do that? And that's basically the idea of what we're trying to do here. Let's see here. I do have, again, my YouTube channel. I used to be very proud of my YouTube channel. People used to say, "What do you do?" And I was like, "I do YouTube," because I had tech education and stuff to be proud of. I will tell you now, if you go watch my YouTube channel, it exists. It pays for this. It pays for this very well, but I don't know. It is what it is. She watches my current channel. You're good? Okay, God bless. There you go. Let's see, as we get into this, one of the big things is, so I am a systems person. When you get in the technology world, a lot of people, when they say they want to get into technology, they say computers. And you're like, what the hell does that mean? That doesn't mean anything. So I'm systems guy. I got my MCSE, like I say, I started in the Army back in 1996. I got my MCSE back for NT4 back in 2000. So I love to understand how systems work together. So basically what I do, what my profession is I take systems that other people have created, and then I duct tape those damn things together to actually create a solution. So one of the important things, and I talk about this with AI, so a big thing that comes up with artificial intelligence right now, and especially programming and technology, is this whole concept of, this is too hard. Eli, I'm not smart enough to do this. And what I'll tell you is AI is hard. What OpenAI is doing, what their engineers are doing, I can't even start to conceive. I would not understand the email that they read when they're communicating about it. Here's the thing. We're not actually dealing with this. We're dealing with APIs, or like with something called Ollama that we're going to be dealing today. We deal with a framework. Here's the thing. This takes years and billions of dollars to create. This you download for free or pay a couple of dollars, and it takes you 5 lines of code. I can add AI to my project with 5 lines of code. A 9-year-old can literally do this. So you don't have to be that smart. So that's one of the big things. One of the other things, too, that I've been finding out, again, one of the reasons I talk about starting in technology in 1996 is it sounds like just one of those things to say. But what's curious is once you've been in technology for, I'm almost 3 decades into this, is we have generations, right? Every generation that's in this field is different. As I say, back when I got into this, even when I was in the corporate world, most of us came out of the military. Like, I can't explain to young people in the technology world now what it's like to walk into an environment where everybody has been through basic training. Like, you just go in, you do your job, you don't expect anybody to give a damn about you or the rest of it, and you do what you do, right? And it was what it was. The thing is, as time goes by, there's different generations with different mentalities for dealing with the profession. One of the things I get worried about right now is with artificial intelligence, this is the first time I've seen so many technology professionals completely and utterly depressed. I have seen them arrogant, I've seen them egotistical, I've seen them depressed when they can't get a promotion or whatever. But there's something weird that artificial intelligence is doing to people's minds. There's this idea that like this is the seminal moment in human civilization when everything is going to go to hell. And the weird part is Sam Altman and Elon Musk and the rest of them are pushing this crap too. Like the idea that we will not need humans doing work in 5 years, which doesn't make sense. To be clear, if you've ever deployed technology, it takes so long. Even if they are theoretically correct, it's still 50 years away. Like deployments suck. And so one of the big things to be thinking about with AI is that this is just another stack. Right? We had the mainframe stack, we had the client-server architecture stack, we had the service-oriented architecture stack, we had the microservices stack. AI, when you actually start to look at this is simply a stack. It gives a lot of benefits that we did not have before, but at the end of the day, you have to build it, right? If you go on silicondojo.com, I do these fireside chats. There's this guy, he runs contextual AI. He has gotten $100 million of investment, and his company only does what's called RAG 2.0. It's called Retrieval Augmented Generation. Basically, it's kind of a way to give artificial intelligence a memory. But all it is a single database system. There's no LLM there, there's nothing else. It's just basically a database system. They've already gotten $100 million in funding just for that thing. Oh, another person, come on in. And so it's kind of like, this is what I want you to be thinking about. Like how do you plug yourself into this stack and do something valuable at the end of the day? That's the other thing too. What I try to drive home to students is that you should be solving problems, right? You should have a value. One of the big problems I see with a lot of technology professionals nowadays, again, back when I got into this, we all knew why we were there. We may not have known why we got paid. We may not have known why the hell we got hired. I asked my HR person that once, and it was a very depressing story. Anyways, you might not know why you're there, but you understood what your position was, right? You need the servers to function. You need the printers to print. You need VPNs to VPN. So you know why that position needs to exist. One of the things I've noticed with a lot of people nowadays is they don't really understand why their position exists. It's not simply why they got hired or why they're getting paid. If you ask them, why should the company keep your position, they'll kind of look at you slightly stupid. And that's one of the things I'm trying to do with these classes too, is if you're in that position, if you can't argue why your position should exist, regardless of whether you should be there, that's a bit of a dangerous story. So anyways, so all of my classes, just so you know, I talk a lot about total cost of ownership, return on investment, institutional knowledge, that type of thing, because I argue this is the most important thing. When you go to your bosses, when you go to your CEOs, when you go to your executives, you should be able to explain why the hell your position exists. That's the first story. Then you get to why the hell you should be hired for it. Hello, people coming in. Ooh. There you go. Yep. Let's see here. So again, my story, just so you know, so I was in the Army. Got my MCSE back in NT 4.0, was doing great until the dot-com bubble burst. Wound up, just so I might foreshadow some of your people's stories. You do not know what the pain is like to have the Army experience, to have a bachelor's degree, to have your MCSE, to have your 100 hours of VIA systems training, who have done $500,000 build-outs, and you are getting laid off of a pizza delivery job because nobody cares. That's actually how I started my consulting company. I just started putting up pull tab signs, hoping I could pay the bills. Anyways, became a consultant, had 9 employees at one time. Great recession happened. Decided I really hated employees, to be quite frank. Went back to college. I was in a master's degree program, and this is one of the things you'll notice in my classes. Again, we're always talking about ROI. Why the hell do you matter? Because I was in a master's degree program, and literally, as I was sitting there, I realized I didn't care. Like, I sat there, I realized the instructor didn't give a crap about what he was talking about. I realized the students didn't give a crap about what he was talking about. And I had 9 employees 6 months earlier. I would not have paid them 25 more cents an hour for what we were learning. And I had this idea, what if there was on-demand streaming video classes to teach what we actually get paid for? So anyways, that's kind of what happened. One thing led to another. I got to YouTube, and now I'm trying to do this. People don't understand what we do, blah, blah, blah. What is Silicon Dojo? So the big thing here is I'm trying to take the concept of what I've learned in the YouTube world. Basically, I call it free to the end user. So in 2012, I was at the AOL building trying to explain what the hell it is that we do. Again, that's an interesting thing in the technology world. What happens when you're very successful at what you do, but nobody understands what the hell it is? And you're like, words, what am I doing? So I was like, free to the end user technology education, right? So the students get the information for free. I get paid quite a significant amount of money back in the day. And advertisers got to put their ads on my videos, and they were happy because they got high quality ads. And so that was the question: is can we abstract out the financial component of education from the actual education itself? Right now, we are crowdfunded to a decent amount of money. We need more. If you go here, it says support Silicon Dojo at DonorBox. If you click on, what is that? The owner of this website has banned the Cloudflare. Is this Cloudflare? Anyways, there should be a donor box link there. Anyways, donor box link, people can throw in money. My viewers have thrown in a significant amount of money over the years, and that's currently how we're getting paid. So if you like these classes, click on that. Hopefully you do not get this, and throw in a couple of dollars. It would be ever so lovely. One of the big things with this too is if we pull out the financial component, we pull out the certification component, we pull out the other components, then you're only here because you want to be. I'm only teaching you because I want to teach you, and you're only here because you want to be taught. And I've been in so many classrooms, that sounds like a hell of a lot more enjoyable environment than most people not wanting to be here, right? So that's kind of what we're doing here. One of the big things is help each other. We talk about dojo. I spent about 20 years doing martial arts. There's a concept with martial arts system, that the old thing with belts, that they didn't have belt colors back in the day. You simply got your white belt when you started, and it became black over the years of training, right? We don't have belts here because I'm not going to get into it. The big thing here is as you help each other, you build your reputation. You get to whatever level when you're like, I'm having a problem, and somebody says, oh, go talk to that person, right? That's how you kind of build your reputation here and go up in levels, I suppose. Do the hands-on work. Unless you really don't want to, you're not forced. But anyways, a lot of people feel like they come to technology classes and they're gonna get it through osmosis. Eli, I don't have to do it, I understand. It's like, no, you don't understand until you like missed the comma, or you put a double quotation mark when you should have put a single quotation mark, or a semicolon. You put the semicolon one line after you should have put the semicolon, or you used a space instead of a tab. You don't know until you screwed up the space and tab deal. So anyways, if you're gonna come to these classes, you don't have to do the work, you don't get grades. I would recommend that you do the work. More people, come on in. And one of the big things, if you're new here, again, these classes are for everybody. As long as you wanna learn, show up. I do not care. The big thing is if you're like, I don't know if I'm doing well enough in these classes, the only question you should ask yourself is, did you learn something today? If you learn a little bit, if you learn a tiny little bit, and you do that, multiply by 200 times, you'll be fine. Not gonna get into that. And the material is free. Just so you all know, I haven't figured out licensing schemes, so I don't know what the license is. The big thing with this is the way that people in Africa and India and Pakistan use my content. My goal with this particular program is if they take this and then they start teaching classes wherever the hell they're at. I think that's the interesting concept here. So with any of this, if you like this, you can just take this material, you can download it from GitHub or Silicon Dojo, and you can teach your own class. So all of this is basically use as you see fit. If you can't show up, please cancel your RSVP. Okay. Yep.
The link for the donor box didn't work when I went to your site and went, so I don't know why yours didn't work.
Oh, yeah, there you go. I'm using a VPN. Maybe it doesn't like my VPN connection for some reason. Anyway, as long as it works for you. Yeah. As long as it works for you, Pia. That's the big thing. Again, one of the big things with wanting this to be free is anybody can sign up. If you need to cancel, just cancel, just so I know. We will be using Meetup for the RSVPs. So we have, oops, where's my thing? Give me my bar. Oh, it doesn't even give me my bar? What the hell's going on? Was it? No, it's not helpful. Where's my, oh, I don't even know what this is about. Fuck.
Yeah, I use a VPN most of the time when I get stuff like that a lot.
Where it just takes your bar away?
Command F.
Command F? So what do I do now? Enter? I mean,
Escape. I just hit escape.
no, there we go. All right, there you go. Hey! Anyways, if you go to silicondojo.com, you can RSVP. This is just, we have a CRM solution on the back end, just so we can keep track of people if they come to classes over the long term. Try to sign up just on Meetup, though. We'll just use Meetup as the RSVP, the official RSVP system. This is just kind of for tracking purposes. Let's see here. Anyways. Yeah, gone through most of it. I'll deal with other stuff as we do more classes. The only big thing is for when we're here, again, people have gotten a little lonely with work from home. There are no stupid questions. There are inappropriate ones. So if you have a question about the material, please ask it. I will answer it. If you have a comment about I would do it this way or that way, glad to hear it after the class or something along those lines. Just, just keep it kind of within the class. I don't know. Does that all make sense? Cool. We'll get to the actual class. Okay, everybody got their material. Dun, dun, dun. Okay. So intro to AI LL systems with Ollama and Python. So basically what we're going to be doing today is we're going to be working with what is called an LLM framework. It is called Ollama. What this does is it allows you to run large language models directly on your computer. So you don't have to go to OpenAI, you don't have to go to Anthropic, you're running them on the system itself. The good part with this is with Ollama, you can use a programming language called Python to interact with the LLM. So you can actually start building your own LLM applications to do exactly what it is that you want to do. Again, one of the warnings that I give technology professionals right now is everybody thinks swiping a credit card and using somebody else's LLM solution is a moat. Like, I know how to use Claude, which is great for about 6 months. What I would really recommend for people to think about doing is how can you build LLM solutions that either you or your organization can own, right? Things that are bespoke specifically to what your company is doing and that they can actually use that as a valuable asset. And that's kind of what we're going to be going through today. So I'm going to be showing you how Ollama works, how Python works, how we can do injections to actually guide how the LLM is going to answer questions. And then we're going to build on that to actually create a little web application. So we're going to use something called the Bottle Web App Framework. And so you're going to have your web browser, you're going to be able to plug in a question, it's going to ping the LLM, it's going to receive an answer, and it's going to pop that up on the screen. So you kind of get an idea of how everything kind of works together. With this, all you need is a Windows, Mac, or Linux system with at least 8 gigs of RAM. Just so you know, with troubleshooting, so everybody has their own computer, so I will try to help you troubleshoot. We will see how well this goes. I will say with Linux, I have to be careful here. I know Ubuntu. I know Debian. So if you have a Debian Linux distro, I can probably help you out. If you're using Fedora, as I said, I remember Yum. That's about all I remember. So we'll see how well that goes. When you're running Ollama, basically you're going to download a model. So some of these models are 2 billion parameters. Some of these models are 458 billion parameters. Basically, the size of the model at 2 billion should equal about the amount of RAM you have on your system. So if you have 4 gigs of RAM on your system, you should be able to run a 2 billion parameter model. Should. If you have 32 gigs of RAM on your system, you should be able to run a 14 billion parameter model pretty well. So one of the things is if you're playing with this for coding purposes, just kind of look at your computer. GPT-OSS is OpenAI's new open source or open weight model that actually works really well. I'll show you that on my system. If that doesn't run for you though, one of these smaller models, one of the ones we're going to use today called Pi 3 is kind of really small and that will actually run on your system. The thing that you have to realize is when you're running this, especially as you get into more complicated projects, it can be difficult to understand when you screwed up the code or when your LLM is just really fucking quirky. Like some of these projects, I actually had to shift the demo to be using the OpenAI's model because when I used Pi 3, the responses I got back were so damn nonsensical. Like I literally spent half an hour troubleshooting my own code just to realize that no, Pi 3 just kind of is weird. So one of the things to think about. With Ollama, for a lot of these testings, you don't need a high-end NVIDIA GPU. Again, a lot of this stuff, I have old 2012 MacBook Pros. Most of these projects will actually run on one of those old things. Ollama will detect that you don't have a GPU and will simply run it on the CPU. It'll be a hell of a lot slower, but it should run as long as you have enough RAM. Yep, so I'm gonna go through some stuff today. Okay, so introduction. LLMs are a single component of the AI system, much like a database is a component of a CRM solution. So again, a CRM, so somebody says, my company has a database. It's like, do they have a database or do they have a CRM solution that the database is part of? That's one of the things to think about. When people talk about the LLM, are they talking about ChatGPT, which is a full-fledged product, or the LLM, which is just the component, just the large language model? Let's see here. Yeah, solutions such as ChatGPT are built with a number of different technologies beyond simply the LLM itself. One of the things you'll hear about nowadays is that LLMs have gotten a lot better at math, and that's generally not the case. With ChatGPT, LLM has been better at figuring out what a math problem is, sending that over to a math routine, getting the answer back, and then spitting that out to you. And that's the kind of thing that you need to be thinking about, right? Is it the LLM that's solving the problem, or is the LLM creating the equation, sending that to a math subroutine, and getting a response back? That's the kind of thing we'll talk about today. Let's see here. One of the big things with LLMs that's getting really confusing, why I always say quote unquote artificial intelligence, it's very important to understand right now, this is not, and this is not me being snarky, this is just me getting more and more pissed off for the past couple of years over this terminology. Artificial intelligence is a marketing term so that Sam Altman can get $4 trillion of investment. The issue with this, and it's not, like when you get into this, people get like, ah, but like when you look at LLMs, one of the problems with LLMs is people say, why is this not safe? Or the big ones that Ars Technica will talk about is, why is it racist? Why is it sexist? Why is it blah? It's not, right? As I talk about, if a teenage boy types 8008 into his calculator, shows it to his friend, and his friend giggles, that does not mean Texas Instruments is sexist. That means teenage boys are doing teenage boys crap, right? When you look at LLMs, it's important to understand what an LLM does is there's these things called tokens. It turns words, parts of words, and symbols into tokens. It figures out the statistical relationship of these tokens in a three-dimensional array, which is really cool and complicated and way the hell over my pay level. And anyways, so basically when you're asking it a question, it's figuring out the statistical relationship of these tokens, not even words, what these tokens are. That goes in the system. It comes out with other tokens that match the statistical relationship. And then it's basically like cards. It flips over those tokens to say what those words are and what those sentences are. So it literally doesn't know. It doesn't know what a boy is or a girl is or a cat or a dog or a house or a car or any of that stuff is. It simply understands the statistical relationships between tokens. And can you hand that to him back there? And so this is the important thing to be considering. Like, so one, oops. Yep.
I thought that it's not, I thought that bias that is discussed is more just because what it's been trained on has bias. It's not because the system itself has bias.
Well, but that's the thing. So again, the training material has bias. So it's simply, it's been...
It's mimicking the bias of the stuff it was trained on.
Yeah, yeah.
Okay,
So it's spitting that out.
Yeah. I just thought it's like, sometimes people don't discern the difference between them, but I understand what you're saying. Okay.
Yep. Well, and that's the thing to be thinking about, like with these LLMs. What I find interesting, and to be clear, IBM does not sponsor me. If you work for IBM, I will take money from them though, is I just did a fireside chat with the VP for AI models for IBM. And he was talking about Granite. So there's a Granite model that they provide, actually really quite impressive, but I don't know, most people don't hear about it. One of the things that they did is they only trained Granite on business communication. So you hear, like the weird thing is, like you hear about OpenAI and all these companies trying to scrape Reddit. So think about it, like they're literally scraping Reddit for statistical relationships on words, which,
Isn't that where it gets most of his info from now?
yeah, God knows. But that's the thing. And so like IBM was like, well, we don't want that crap coming out. So they trained just on business communications. And so you think about that, the statistical relationship of words of business communications is gonna look a lot different than the statistical correlation of words on Reddit. So.
That's emojis.
What's that?
That's emojis.
Yeah.
Did you say their model's called Grant?
Granite, like the stone.
I thought they had a Watson or something.
No. Oh, that's a whole. There's an interesting fireside chat. That's its whole thing. Granite is the model, though. So again, LLMs aren't racist, sexist, good, or evil. They're just really complicated calculators. And so if you start understanding that AI is just a really complicated calculator, it makes it a hell of a lot easier to start understanding these systems and grasping what you're going to get out of it. Again, like the interesting thing that I find since I do commentary videos on YouTube is like I'll read Ars Technica or Engadget, and they'll talk about these horrible things that that ChatGPT said. And literally, it'll be 20 very guided prompts to get this ChatGPT to spit out this god-awful response. And again, like you can just sit down at Word. On Word, you can type out some really horrible things. That doesn't mean Microsoft is X, Y, or Z, right? And so I think that's one of the things to be thinking about with these systems is why are things coming out? And that's where we talk about like with LLMs, are you using Grok? So Elon Musk has stated Grok's selling point is it's not safe for work. Like that's literally its selling point. Whereas Granite has been trained on business communications. So something to think about with an AI system that you're deploying is who are you deploying to? Do you want Grok or do you want Granite? Like, and that's a decision point. That's a decision point. So the LLM, the results will be skewed by the data that it's trained on. So again, I'm talking about that with Granite. And outputs are biased by training and data in ways that might be unexpected. So one of the big things to understand, so again, with Silicon Dojo, look, I've always done support. I've always done support services. My customer at the end of the day has always been the client, always been the user. As I tell my students, CEOs write the checks, or CEOs sign the checks, secretaries write them. If you want to make sure as a consultant you keep getting called back to a company, kiss ass to the secretary, not the CEO. CEO just wants to make sure the profit loss statements are proper. The secretary cares about if you're nice to them and the rest of it. So that's where like nowadays, like this whole diversity and all that, I don't know, it's kind of really weird. The big thing that I try to talk about with people is if you're in the tech world, you're supporting users. If you piss off your users or they refuse to use your system because it's doing something that they find to be inappropriate, then they're not using your system. Doesn't matter if you like it, doesn't matter if you care, doesn't matter if you understand. If your customers don't use your systems, you failed. So I bring this up with LLMs because it was really weird, right? So a couple years ago, things were going on in the news. People were talking about how these LLMs were all these different things. So I was just curious. So I went to OpenAI. So OpenAI has their API. So I was doing classes on APIs. And so in the API, I just plugged in different things. Let's hear about stories about people, right? So I put in, tell me a story about a white guy. And I put in, and it gave me a story and whatever. The person worked as a manager, did this, that, or the other. Give me a story about a white girl. Gave me a different story. Latino, boy, girl, Asian, boy, girl. All of these different stories. Again, like them or not, they were kind of blasé, but they were different stories. What was fascinating, I said, okay, give me a story about a black girl. And so she goes to school, and then on her way home, she sees a friend of hers that's being bullied by multiple people, and then she stands in to stand up for the person that's being bullied. And I'm like, okay, well, that's a little bit on the nose for 2022, but fair enough. Okay, give me a story about a black guy. Black guy goes to work. While he's at work, there are multiple people that are bullying somebody at work, and he has to stand in to do something for those people. Like, that's kind of weird, almost the exact same story. Again, black woman does something, and then multiple people are bullying somebody, and she has to step in. And it was a very curious thing to simply say that one single identifier, and all of a sudden the stories start to correlate again around one particular theme. And so something to be thinking about with this, again, however you feel about those particular stories, don't care, is that it happens. And one of the things I'm going to be showing you in one of our examples is we are going to be pulling out an identifier about a person automatically, right? So one of the things we're going to be doing is we're going to use something called a REST API call. We're going to get what the external IP address of the person is, basically get what country that they're from, and then when they ask questions, the question will be based on their particular country. If I say, who is my president, and I'm in France, it'll say, the prime minister, I think Macron is the president. If I say, who is my president, I'm in the United States, it'll say, Trump. One of the things you might not be expecting, especially if you're pulling in data, this information automatically, is how is your LLM correlating things in ways you never even conceived of? And so that's something about when we talk about diversity and we talk about making many different people use your systems, have lots of people use your systems to find out where it's giving responses that it would not never even crossed your mind. You need to test your AI products, again, on diverse user groups that closely emulate your user base, and skews to poor reception from users to find any gotchas. Again, I think this is one of the things. So I was using OpenCV. So OpenCV is a computer vision framework for Python. We'll probably have classes on that in the future. And I'm like, show me human faces, right? And so it gave me a nice bounty box for this, and it also gave me a nice little bounty box for my Chihuahua, Peanut, who has now passed away. One of the things to be thinking about, again, in the modern world, as I say, I have to be very careful with this particular story. If I was create an AI system, monkeys would not exist in my world. Because think about this. If you're using AI systems that are doing recognition or whatever else in the modern world, and it triggers in a way that might really piss somebody off, do you even want it to be able to respond in that particular fashion? And this is something that you really have to be thinking about. Again, face recognition. Is it cute or is it vile? How dare you call that Chihuahua a person? And you got to play with this. Again, like I'm an Aspie, so I am just fascinated with what pisses people off in the world. Again, I talk about this like with minimum wage. Thank God I'm not an employer anymore. I'd lose my damn mind. I've talked with many people about they have in many places raised the minimum wage to $15 an hour. But the people that were making $15 an hour now demand more money. So if you were making $15 an hour and somebody else was making $10 an hour, not only does the boss have to raise the person from $10 an hour to $15 an hour, but then they have to raise you from $15 an hour to $18 an hour. And I've talked with people, and I'm like, I don't understand. You were making $15 yesterday, an hour yesterday. You're making $15 an hour today. What's the difference? And they say, it's minimum wage. I am worth more than minimum wage. And I'm like, and I walk away. But the important thing to understand is like how people respond to your system, and how you respond might be entirely different. So when you're going to be creating these LLM systems, or these AI systems, you're going to be using a lot of different things. Again, these are going to be systems. These are going to be a stack. It is not simply the LLM. Oh, this is going to be weird. Okay. Where is my marker? I found the perfect marker, and then I lost the perfect marker. Now we'll use the imperfect marker. So when you have the LLM, so the thing to be thinking about with these LLMs is that there's going to be a lot that goes into the system, right? So the LLM here, large language model. So this could be the large language model. It can be the reasoning model. There's a lot of different M's. Anyways, one of those models, right? So this is the model itself. You can sit there, you can plug in questions, and it can respond. But in order to...
So you want your camera to show?
Oh, yeah, whatever. They just have to know that this is happening. How many people are watching? I've got 70 people. Anyways. See, you should be, if you want to watch the board, you got to be here. Anyways. So the LLM is kind of the center of all this stuff, but it's only one thing, right? So we're going to be using this language today. It's called a back-end programming language, and we are going to be using Python. I do believe you can use Node if you want to, something called Node.js. You could use that as a back-end language to talk to that. On top of that, for Python, in order to get a web application, you then need what's called a web app framework, and we are going to be using, my current favorite is a Bottle web app framework. So you're going to communicate into Bottle. Bottle is going to turn this into Python. That is then going to send this to the LLM. The LLM does have a lot of information in it, but only has so much information. So it can go out and it can use something called a REST or other API call. And basically, it can make a call out to other data sources to bring information in. There's something called RAG, Retrieval Augmented Generation. We'll have a class on this in the future. It's basically a very sophisticated database system. Also allows you to keep data or information. You could have a database or other data store for memory. So one thing to realize, like when we're talking about the LLM, and people say the LLM remembers, no, it doesn't. Unless you created a memory, it doesn't. And so you can create a memory for the LLM that will create a memory of this conversation or whatever else, right? And so this is what you start thinking about when you start creating your overall AI system. It's not simply the LLM itself, it's all of these different components that come into it and whatever component you do or do not need. The other thing too is, again, you can have like filtering systems. So I'll show you how this works. You can have a filtering system. It can be very simple, such as a keyword filter. If you say hipster, don't answer that question, right? You can also, one of the things I'll show you is you can actually use multiple LLMs. So IBM has been talking about this a lot lately, the idea of stacking LLMs. They talk about platforms using 10 different LLMs. Right? So one LLM tries to figure out what it is you're asking for. The next LLM figures out what subsystems are required in order to solve the problem, so on and so forth. So one of the things that's interesting here is when somebody asks a question, you can actually have it go through an LLM routine to say, is this an appropriate question, right? So if you're creating an AI system that's going to support your users' coding, you're going to create the Claude for your system, right? You don't want your users asking anything other than coding questions. So one of the things you can do is you can say to an LLM, hey, is this a coding question? If it is, pass it on to the other LLM. If it's not, bounce it back. Because you do have to be careful. Again, employees and people, holy hell. Again, I used to install digital surveillance systems. Oh, they were money back in the day. One second. And the biggest thing with digital surveillance systems, people think that was about robbers and it was about thieves and all that. Hell no, it was about employees. Employees are the biggest cost for most businesses, right? Doing things weird. And it's kind of like there was just a kid that got the police called on him because he was at his school and he literally plugged into their ChatGPT or whatever, and basically said, how do I murder my friend? And again, think about this. If you're running a junior high school and somebody starts asking the AI about how to murder their friends, you probably want to do something about that. And so, again, it's amazing what people do. So you can have kind of these filtering systems built in there. Yep.
How is stacking LLMs different from agents?
So agents, well, agents are its own little world. So basically what agents generally are supposed to be doing is agents are communicating to do the action. So if I say, hey, computer, nothing's running. Hey, computer, schedule an appointment with Bob at 2 o'clock tomorrow. So basically what the LLM would do, the LLM would figure out what command it is that you're trying to do, so it would parse with the variables or whatever, and then basically that would be sent to an agent. And so that's using that whole MCP thing. We'll have a class on that later once I figure it out enough to teach it. Anyways, and basically that agent will then essentially send the command to the API. So you say, hey, create an appointment with Bob. So it would then take that, format that into something that Google's API would understand. It would then send that to Google's API. Hopefully you get the OK response back, and then you go from there. So agents do actions. Agents do actions.
So then what you're describing with the stacking is about really like process mapping, decision mapping, basically, in a way.
Yeah.
Not mapping, but basically it's doing the decision mapping actions, right?
So yeah.
Deciding and then deciding whether it passes it on or somewhere else.
Yeah. I'll show you with like the filter. We'll go to it. We'll go through a demonstration. Yep. Let's see here. Large language models. So when we talk about large language models, I kind of talked about that before. So you had the billion parameters, so 2 billion, 7 billion, 480 billion. That's one of the Llama ones that came out. Basically, the size of the parameter is about how much RAM you need. So if you have a 480 billion parameter LLM that you download, you need 480 gigs of RAM, more or less, to run that thing. You got to decide, how much you really care about that. You do have quantization. So what quantization is the compression of these models to make them smaller. This uses floating point math, which again, I'm an MCSE. Don't quite understand it. Apparently, there's the initial model when it comes out is 32-bit floating point. And then quantization compresses it. So you can have 16-bit, or you can have 16, you can have 8, you can have 4, and you can have 2. So basically it's taking that model and it's shrinking it down so you can have a larger model that runs on a system that has less RAM on it. This is where, or VRAM for your GPU. This is one of those things where testing is going to matter. Is it going to matter for what you're doing? Who the hell knows, right? You might want something that has more parameters to it so that it has more knowledge to be able to answer more things, but it may have less accuracy as you compress it. So play with it, basically. Context, let's see here. When you hear about context windows, the context window is when you send information to the LLM. This is basically the question and everything that you're sending to it. These windows now can be absolutely massive. So when I started playing around and doing classes with OpenAI's API, their context window was 4,000 tokens. So 1,000 tokens is approximately 750 words. So 4,000 tokens is approximately 3,000 words. Approximately, because a token is a word, a piece of a word, and a symbol. You average that out to 750 words. Nowadays, some of these context windows can be 1 million tokens, which seems great, which seems wonderful. Unless you're the one who has to swipe the credit card or buy the computer. Remember, the more information you send to the LLM, the more resources are going to be consumed in order to give you back a response. So one of the big examples that I give with things like the context windows is if you go to a web page. So you can use a module called requests to get an entire web page from a website. You can go to Ars Technica, you can download, you can grab the entire web page in Python, and you can send all of that to OpenAI or to Ollama or whatever else. The thing is to remember, when you download an entire web page, not only are you getting the text that you care about, but you're also getting all of the JavaScript, you're getting all of the CSS, you're getting all of the XML, you're getting all the hrefs, you're getting all the other stuff. So a 600-word blog post, that would be less than 1,000 tokens. Once you add in all of that other text that comes along with it, might end up being 20,000 tokens. Like simply, and so like we're an example, we're going to use a module called Beautiful Soup. And so what Beautiful Soup does is it goes to a web page, only grabs the information that you care about and sends it. So what you have to be careful now is with these massive context windows, right? This is one of the problems we get to in the technology world, right? You allow people to be able to do so much, they get lazy, right? So they start sending 20,000 token things instead of trying to reduce it with a couple of lines of code. So this is going to be one of those things that you have to be concerned about when you're sending stuff to the LLMs, is how can you reduce that context window? That's where we talk about RAG, which is called Retrieval Augmented Generation. That's where you have a database of information, and essentially what happens is the RAG system tries to pick out only the bits of information that might be relevant to your particular query, and only sends that to the LLM. It doesn't send everything. So let's say your company has an entire manual of how people are supposed to do stuff at your company. Let's say it's a 300-page manual. Now, with these context windows, you could send that entire 300-page manual along with your question to the LLM, and then it's going to churn through and it's going to try to figure out what the answer is. Or you can use a RAG system or some other system that'll go through, find only the specific paragraphs that are talking about whatever question is that you have, only send those to the LLM, and then it'll be able to answer it with a much smaller context. So it's one of those things to be considering. We talk about prompt engineering. So 2 years ago, prompt engineering was the cool thing. Nowadays, it's context engineering. Prompt engineering is simply how do you modify the prompt. So there's things called prompt injection, that type of deal. When somebody asks the question, how do you modify that initial prompt to get the best answer from the LLM itself? Like you might give it an example of how you want the text to look, that type of thing. When you start talking about context engineering, this is where you're sending, when you're engineering all of the information that's going to be sent to the LLM in order to answer your question. So this is where, like with a prompt engineering, you may tell it, I only want the answer to be in 50 words. I want the answer to be formatted in such and such a way, blase, 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 right? That's the basic stuff with prompt engineering. With context engineering, this is things where you can add memory. So it's like, okay, here's my prompt, and here's the memory of the conversation that we've had for the past day. So based off of my prompt and what we've been talking about, give me the appropriate answer. So one of the examples we're going to have here is I'm going to show you where we create a memory system. And so I'm going to say, like, who was the president of the United States in 1980? And it'll say Carter. It's either Carter or Reagan. Anyways. And then I'll say, who was he married to? And since it now has a memory, the memory is going along with that context, it will then say who he was married to. And then I'll ask, how old was she when he was made president? And then because that memory goes along, it knows what she is, and so it'll give, hopefully the appropriate age for her. And so that's what we're talking about with context engineering. It's not just the prompt itself, it's all of the information that goes along. Let's see here. One of the big warnings that it will give you is with AI, in the AI world, things are changing nearly daily in AI, and this is not a figure of speech. So I've created many classes. So I've been doing these in-person classes for about 5 years. I have classes on Python and SQL and all kinds of different things. It's great. I created those classes. When I want to teach it, I dust it off, verify the code still works, and teach it. No big deal. Oh my golly. Every time I teach one of these damn AI classes, man, I would have taught one of these AI classes a month ago. I go to run the code. Fails the hell out. Why is it failing out? Because they modified something. Like the big thing now is with the responses, and I'll show you this in the code. When you get the response back, it's a set of data, so it's a dictionary list type thing. So you say what the variable is and what the index of where it's supposed to be. And so before that was with the brackets, and basically like an array, you just say where it is. For some reason, they all decided that they like classes better, I guess because it looks more like JavaScript. So now instead of doing the brackets, you do response.message.content. And just because they decided they preferred that better. Like literally for 2 years it was one way, and now all of a sudden it's a different way. Why? That's the thing, like with the Ollama, the code now is different. So I've been doing a lot with Ollama over the past couple of years. When I started doing this, doing the stuff for this class, literally the code is different than it was 6 months ago. So that's one of the things you do have to be careful about when you implement these systems, making sure you understand things like version control, so that if multiple people are working on your AI system, you don't start to get some really wonky things going on. Okay.
Even if it's a closed database as opposed to an open database with syndicated data coming in all of it.
What's that?
If it's like my company had built a chatbot,
Yep.
but it's a closed system for an educational institution, where the information that it can get from the chatbot is only from that closed data system.
Yeah.
So
Well,
would that still be an issue, that same thing?
Well, no, so basically what it goes to is, when we're looking at the code, right? So again, as I say, 5 lines of code. This is the entire code here. So all that matters is if this has changed. So like if you have a new intern that comes in and installs the latest version of whatever it is that you're running, does this get modified? Or, that's the whole thing you gotta worry. So it's like they're running it on their test system, works fine, you deploy it, and you're using an older version, and so it fails. Yeah, yeah. And that's one of the big things too to be thinking about. Like when we start talking about this AI stuff as systems instead of one single product, remember when the LLM gives you a response, most of the time you're gonna have to parse that response. You're gonna have to read it somehow and then decide what you're gonna do with it. And all these LLMs, the responses are different. And it really is a problem. Like, because if you have Python, it's very easy to look at a response, see what the response is, and then modify, right? But like the latest version of the latest version of the model might give you a different response. You go to a different model, you get an entirely different response. Like one of the interesting things, I'm going to show you how to do an auto blog at the end of the class. And so it will read from somebody else's blog post and then automatically create a blog post for you. Well, one of the weird things is sometimes it'll add in, like if you go to Gizmodo will tell you how long it takes you to read the article. And so it will just sometimes it will automatically add the read time. And so if you're going to be creating your own system like this, you have to know to remove that. Whereas if you were using one LLM that never added a read time, everything was fine. You switch to a new LLM because maybe it's more verbose, and all of a sudden you got read times and things. And like that's where you really have to understand these systems are quirky, to say the best. So, okay, so we are there. Any questions up until this point? No? Oh, yep.
I guess I'm going to wait till you're talking about memory, but when you mentioned this like a chatbot, you do want the notion of a session, and with the big models, we're used to remembering what we talked about,
Yeah.
and then it knows that somebody else logs in and they know what they're talking about.
Yeah.
But if you didn't add the memory to things like Ollama, then it won't remember it all, really.
Yeah. Yeah. So yeah, memory is a subsystem. If you don't create that, it doesn't exist. Yep. Okay, so we're going to be using the Ollama framework. So I did put it there, correct. Somewhere I put ollama.org. Don't go to ollama.org, apparently. You can download Ollama from ollama.com. If we go to the website, basically, ollama.com. So if you go to ollama.com, you get this, and basically you're able to download for Mac, Windows, and Linux. You click on that. You see you got the Windows download, Linux, you run a command prompt, or you run a command on the command prompt, and Mac, you also do the download. So what happens here is you will download Ollama, you run through the routine to start it. The big thing, if you're going to be using Python, is that Ollama has to be running for Python to be able to interact with it. Python doesn't auto-start it or anything. So if you'll notice, up here, I've got a little llama thing that shows me that Ollama is actually running. So if your code is failing for some reason, most likely Ollama isn't running. One of the things I will warn you is from a security standpoint, when Ollama starts running, it actually also starts running a web service. I forget exactly what port it is, but you can go to 127.0.0.1 : whatever that port is, and it will tell you that Ollama is running. So just be careful with your environment. So theoretically, if somebody knew your IP address, they can start trying to run LLM queries through your computer. Just one of those things. Beyond that, when you come here, you can click on models. So this is where I'll show you all of the models that are available. And again, this is the modern world, so holy crap. I feel like as a technology professional nowadays, we're more salespeople than anything else, like simply knowing what model it is that you want to use. The model that we will be using today, the models, is Pi 3. So PHI 3. This is from Microsoft, so it is a 3 billion parameter model. That's the smallest one, so it should run pretty well on your system. Yeah, runs good enough. Been using it for a while. And then we'll also be using GPT-OSS, and that is OpenAI's open weight model. So you can download that, and that runs pretty well. So those are the two models. Though with the GPT-OSS, it is a 20 billion, so it takes 20 billion, so you probably need about 20 gigs of RAM in order for it to run pretty well. So it's just one of those things to keep in mind. The other thing too is if you're going to be building one of these systems, something to consider in the real world is how many users are going to be running on your system concurrently. So remember, if you're getting pretty good responses as one person in your system, ask what's happening if 2 people, 3 people, 5 people, 10 people are hitting your system all at the exact same time. That's going to be a big question mark. The other thing too to be thinking about, again, from an architecture standpoint, one of the things you'll notice, I talk about architecture a lot. Again, MCSE, love my architecture. One thing to be asking yourself is what is a reasonable time for your responses for what you're trying to deal with, right? So if you're trying to create a chat bot, you need the response quick. So spending $5,000 on a GPU for your server probably makes a lot of sense. On the other hand, if you're going through, and let's say you're turning, you're grabbing information out of documents and dumping it into a database, well, even if it takes 1 minute to get a response back. So 1 minute is horrible. You would never accept 1 minute for a response. But think about it, 1 minute, that means you're doing 60 records per hour. You're doing something like 1,500 records per day. You're processing 24 hours a day, 7 days a week. Frankly, having some crappy ass computer that's been collecting dust for the past 5 years, throwing Ollama on it, and just having it churn for 24 hours a day might make a lot more sense from a cost perspective than going out there and buying a $10,000 server that will do everything quick. So that's one of the things you do need to consider is like what do you want your systems to actually accomplish, and what is the most cost-effective way of doing that? So yeah, anyways, these are all here. So basically when you install it, you're going to install it, and then you go to your command prompt. So you come here, you come to your command prompt. When you want a model, the first thing you're going to need to do is you're needing to pull a model. So you do pull, let's say Pi 3. So this is how you pull the model. You hit enter. It's pulling the manifest. Everything's already there. So you can see, it's about 2 gigs in size, and I have Pi 3 already there. If I want to see,
Where does it go when you pull it? If I pull that, where can I find it on my computer?
it is in a folder in your computer. People always ask me questions. No, there is a model folder. It's a very good question. Where is my model folder?
I'm using something else and I've been downloading models and I don't know where they go.
I'm sorry, what's that?
I think it's .ollama in your home directory.
Is it .ollama?
Option in that.
Can I, anyways,
Anyway,
yeah.
a similar question though is they said it works a bit like Docker, like you can pull there.
Yeah.
But I couldn't find a way to save it out. There wasn't a command I put into the Docker save for a model.
Oh, to put it somewhere else? No, as far as I know, there isn't a command.
I was looking all around for that. That was going to be one of my questions today.
Oh, yeah.
And as soon as you know about it either.
No, I know there's repositories. You can go to GitHub and you can download these models as files, but yeah.
Let's say you download a little pile and then I find you run out of disk, and then you go, well, okay, I'll delete one.
Oh, Yeah, yeah. So let's see here. In order to list what you have, you do list, Ollama list. So this shows you all the different models that I have on here. Pretty simple. And then when you want to run, basically, all you do is you say Ollama, and you say run Pi3. So you hit this, it'll work, and then now we are actually sitting at the LLM. Yep.
I have a really dumb question. I'm on the website.
Yep.
And I'm supposed to download the Phi-3 model, right?
Yep.
Where's the download button?
For the model or for Ollama?
I clicked it for Ollama already,
Yeah.
but I thought I needed to download the Phi-3 thing. Or is that something you...
Oh, no. So that's
in Ollama?
what I was just saying. So that's with the Ollama pull Pi3. That's fine. I don't want anybody to get lost. So you do Ollama, then pull is the download, and then you put in what model it is you want to download. So Pi3 at the command line once it's installed.
It pulled up a cute little window with Ollama.
Oh, no. Go to your command prompt. Go to terminal. Sorry. Command. Okay, now do Ollama. No, Ollama space pull and then Pi3. PHI3.
Thanks.
Yep, there you go. No worries. See, that was an appropriate question. Yep.
So when you did the list command, I saw there was a GPT latest.
No, not pull. Ollama list. Pi3 latest, OSS
GPT
latest.
OSS latest.
Yeah.
Right? Is that like the old way of linking to always the latest version, or what is that? Or is it, if you use the latest, does it change the model every time you try to run it?
No, you do have to update it.
Oh, you do have to, okay.
Yeah.
The latest is just, I guess, whatever is the latest and greatest.
Yeah, great question. Anyways.
This isn't showing it that way, but other models, like if you go to Hugging Face, where a lot of them are at and where you pull a lot from,
Yeah.
you can see where they're just training them and they're releasing them, like doing
Oh,
nightly
it's like
beta.
a
Yeah, it's like a
nightly
nightly or a beta
Got it,
release
got it.
that's updated constantly versus something more stable
Something like- okay.
mainstream.
You're saying that's constantly updated? No. I don't know.
Well, it'll be whatever their most recent updated one is instead of like pinning
Yeah.
to a static version. It's
Yeah, that's what I was
whatever
thinking. If
beta
you're
nightly.
programming and, like you said, right, it changes every day.
Not every day,
No.
but it would be whatever their most recent is.
Got it.
Yeah.
Ollama and things like that do change more often than you'd think. You'll say every week or two or three, you should upgrade.
Yeah.
Yeah, you wouldn't use it if you're trying to build a system.
Build a
for it. I
system.
wouldn't recommend that because you no clue what they pulled.
Got it.
I will look at this afterward. How Ollama was 3 months ago is you did have to update your models. They didn't
Well, yeah,
auto
you have
update.
to
So
update it. It's just that is when you update it, it's whatever it's
latest.
not a named release. It's just
the
the
latest.
latest.
No.
Yeah, I was just curious, so.
Yeah. Okay. Yeah. Now I'm confused. Anyways, okay. Let me try this. Okay. Ollama run Pi3. Okay. So this is where. So this is just Ollama itself. This is just the framework, and it's allowing us to interact with Pi3. So I can say hello, and say hello. How can I help you today? And so this is where you can start to get an idea of how fast your response is actually going to be from this thing. I can say. How big is the world? And so this is a M2 Max MacBook Pro from about 2 years ago. So it's responding about this quickly, which is pretty decent. Again, think about this. You can run this on a Raspberry Pi 4. It will just be a lot slower for you. Yep.
And you're able to run the GPT OS?
Yeah, I'll show you that. To get out of this, because you always need to know how to get out of command prompts, is you do /BYE, not exit, just buy, because I want to be cute, and that will get you out to the command prompt. Yep.
I guess since you're here, there's like Ollama command to show how much GPU you used. And I always find that really fascinating.
Is there? Oh, okay.
I think it's like Ollama PS.
Yes.
I always have to look it up, but yeah.
Yeah, okay.
Isn't that cool? And And so, like, if you have Raspberry Pi, you're not gonna use any GPU.
Yeah.
I
Yeah.
think you are.
100%.
Yeah, 100% GPU. No, that's cool. Okay, so yeah, for the GPT OSS, I'm gonna do Ollama, and this will actually show you how things are different, GPT hyphen. So this is a reasoning model. So when I run this, so you notice it's taking a little bit more time. So I ask it a question. So I can say, how big is the world? Oops, I misspelled it, world. So see, this is how it's starting to do. So it's spitting out all this. Yep. And this is why things like prompt engineering is important, is because remember, if I'm asking how big is the world, I don't want this, I don't want this. And so that's where when you use Python, you can put in a prompt injection. So I can say like essentially how big is the world, if I can know how to spell world, and answer in under 20 words. So basically, I'll show you how to do this in Python, and then that will give you, see, it's still thinking, but then it gives you this answer here. So that's one of the things you have to consider. And so that's where I'm telling you, like these LLMs, the responses are so much different. Pi 3 gave you a pretty nice, concise response, however accurate it is, whereas this gives you a frickin' book, right? So that's one of the things you have to consider if you're using these. And that's basically the idea with Ollama itself. Any questions there?
Do you always have to use that dash to kind of prompt it, or could I just put how big is the world, tell me under 20 words?
Yeah, I use the hyphens just to, so basically, again, what you have to understand is it is not reading. It does not know what world is, it does not know what answer is, it does not know what 20 is. These are just tokens. So the reason that I use hyphens is hyphens are usually used to define separations between things. And so I personally have found hyphens work well for when I'm doing that type of thing. So that's what you have to understand is whatever you put here should be a rather common way of separating things out so that it understands what's going on. Yeah.
What's the dependencies on the speed of the output? Like, is it just the compute power, or is it like different, like the parameters of the model, and if there is any difference?
Yeah, so the 2 billion parameter is going to be a lot faster. So the smaller the model, the faster it'll run because it needs fewer resources. The larger the model, the more resources it needs. And so then past that, it's how many resources you have. So this has 32 gigs of RAM and whatever the hell Apple put into it, so it runs pretty well. If I have the last Intel Mac that came out, and when I run this on that, it does do an output, but it takes a little bit longer. Yeah. Okay, so, yep.
You said that the GPT OSS is a reasoning model, so what does that make the 5.3?
Oh, geez. Yeah, that's where you get all these questions. Yeah, so basically what Pi 3 does is it takes what you have and then it just answers that. It tries to create a relationship with that. What the reasoning models do, and again, I hate these words, but so what the reasoning models do is it tries to quote unquote figure out what it is that you're actually asking, and then it tries to answer based off of that. So
It to be able to handle more nuance in natural language, the reasoning model works better?
yeah, so it's like we need an answer under 20 words. The question is this, provide a succinct answer in under 20 words. So it's trying to give itself more information so that it can find a better answer. Like a good example of this is actually when you get to like the new version of DALL-E. So DALL-E is OpenAI's image generation model. And what's really interesting there now is you plug in your prompt. And so with DALL-E 2, you would plug in your prompt, and then you will get nightmare fuel. Like if you haven't played with DALL-E 2, it is like, what the hell? Anyways, it was technically very awesome. Just, it gives you nightmares. Because it would literally just give you the response to your prompt. The interesting thing with DALL-E 3 is you give it a prompt. What's really cool is it then creates a paragraph story about your prompt. So it auto will create the story, and then once it has this story, it will then create an image based off of that story. So that's kind of what's going on with the reasoning model. Generally, it's considered better. Again, you have to do enough testing to figure out for your particular solution. Yep.
So since you're here, some of these models say like /no thinking, or sometimes you can say something else. Is a thinking model the same as a reasoning model?
Oh,
These words are kind of blurry, but I know in somebody else's model, very like mainly Quinn, the no thinking comes out a lot faster. It doesn't say thinking, it doesn't grind around as much.
yeah. That's all playing with all these different models and figuring out the specific model itself. Again, as I showed, like there's 1,000 different models.
A standard, but that's a famous phrase. That's the nice thing about standards. There's so many of them.
Yeah, I mean, the big problem with a lot of this too is, like I say, for me, I like systems. I like a lot of different things going on. And so there's so much currently going on in this particular world. And so if you want to keep up on it, you like really have to keep up on it. Okay, so let's get to Ollama and Python. So basically with, what is this?
I have another question.
Yep.
In terms of updating models, you were saying that you don't have to update models anymore. So like if we're running.
No, I think you do have to update models. I was asking, the last time I played with it, 3 months ago, you had to update models. That's where I was saying the question. Like, again, these things change. I don't know if.
So is updating it as simple as just running the command again, like just pull whatever model?
It was, yeah.
Yeah, it's just like any piece
Yeah,
of software.
don't forget the
Abstracted away from it being a model or anything fancy, it's still just another component piece of software.
Right. But I'm
Yeah.
just saying, like, do I have to run the command to make sure it updates? Or okay.
Yes, great questions. Great homework for me when I get done at the end of the day. Let's see here. Okay, so let's look at Ollama and Python. So this is basically their example of how you use Python in order to communicate with Ollama. So you'll notice here, so again, if you know Python, this is no big deal. There's a module called Ollama. So however you want to install it into your library, it's pip install Ollama, just Ollama, you install it, and that's where it gives you this functionality. So you install, you will pull Ollama, the function chat, and the function chat response. Normally, you would do chat, comma, chat response. This is literally what their example is, so I just left it this way. I don't know why they do it this way instead of doing the comma, just so you folks know. So this is what the response looks like. So this is right here, basically, this is all the code that you need. Again, all those 11 lines of code, that gives you everything you need to be able to communicate with Ollama with Python. So you need to pull in these two functions. So response, when you look at this here, so this is creating a variable called response. The colon is setting the variable type to whatever this is, and so this is going to come back as a class, just so you know. So chat response equals chat model, and this is where you plug in what model you're going to use. So if you're going to use Pi3, you're going to use GPT OSS, you're going to use whatever else. The important thing is that, where did my little bar go? Anyways, the important thing is that Ollama is actually running. If you try to run this thing without it running, it's not going to work. One of the things you will notice with my code, just one of these things to go over, my educational style is to teach you specifically whatever the hell it is we're trying to teach you tonight. A lot of people, when they teach you everything. So they teach you security, and they teach you best practices, and they teach you everything. And then you don't remember anything, and it's worthless. So to be clear, if you're actually running any of this code normally, you're going to put it into production, there's something called a try except statement. You would try to do this. If it fails, you would do something else. That is what you would do in the real world. That is extra code that I have to explain. So if you do this wrong, it will just error out. You deal with the error. So just so you understand. Anyways, so response is going to be the variable name. You're going to give it whatever model. So you need to have Ollama running. You need to have that model pulled. Role user, there's multiple different roles. Just leave it as user. And then content, this is what is going to be your query. So why is the sky blue? Or your query is just going to get plugged in here. That's all it is. And then you close it out. So you're going to get the value. You're going to get this class back, the value response. So again, there's multiple ways to do this. So the old way, so you would do print, response, message, content. So basically, response variable, message index, content index, That's what you actually care about, and that will spit out the response. Again, the cool way, everybody's doing it nowadays, is response, period message, period content. Either one will give you the same answer. If we, just so you see when I'm talking about the indexes, so I'm going to, right here, I print response. So that's going to be everything that's going to come back. I'm going to run this. There we go. This is going to be a little hard to understand if you don't really understand what's going on, but this is everything at all these indexes. So it's going to say, I used model pi 3, it was created this particular date. It's going to give me a duration of how long it took the response to come back. It's going to give me a whole bunch of different things. The important thing here is content equals, and this is the actual answer. So again, that's the thing to be thinking about when we're programming. I don't want to just give this to the user. This is going to be a whole bunch of information they don't care about. But it might be useful for you. Like the duration, how long did it take? You might want to record that into a database to understand how your system is performing, right? There might be things that you want to pull out of this, but generally you don't care about. Whereas if all we want is the actual response itself, so this will print response.message.content. And then that will give me, there you go. The sky appears to us due to a phenomenon, blah, 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 blah. So that gives me just the answer that I'm looking for. And so this is all there is, like Python and Ollama, this is all we're talking about. Any questions on that? No? Cool.
In the previous output, it showed the user as assistant, not user, the role.
Oh, did it?
Yeah, role showed up as assistant. Unless user is a variable and the user is assistant.
Images none.
Role assistant.
Oh, crikey. Oh, where are we looking at roll? Roll, 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 roll.
6233233.
Wait, what's that?
2 down.
There, right there.
Right.
Where it is.
Down?
Assistant. Right there.
Oh, role equals assistant content. Huh, that's curious. I do not know the answer.
That's probably the user, right?
Yeah, so you give it user role here. So user roles can be, administrator, user, or assistant. So user is basically when you give it the question. I don't know why it says assistant.
The LLM is acting as an assistant, so I thought that's why it says role assistant. Because it's the response, the message.
Generating an answer, yeah.
Yeah, so that's what I was thinking.
Oh, that sounds-
I don't know.
Well, I was expecting user to be there, but maybe
It's a
assistant
response
is the
from the
user.
assistant.
Yeah.
Who's,
The
it's a
fa-
response from the thing that's an assistant.
Maybe. The fascinating thing about being a teacher is you're like, I never even saw that before. To be honest, I never even saw, like, sure, I will, more research for me. Okay, other than that, is there any questions? No? All right. Okay, so let's go to LLM injections. So let's go to, so you go to page 8, and we go to injection. So here's going to be a little bit more complicated. So this is generally more or less what a program starts looking like. And again, this is the important thing to understand. Where people say, like, do I need to be smart to do AI or programming or whatever else? No, all we're doing is we're simply building components. Again, you may not fully understand what this is, but you'll learn. It's just simple stuff to understand how it all fits together. All I'm doing here is basically I'm turning this request into a function. So it's a reusable function, 1 second. And then down here, I'm doing something called a while true loop. So what's going to happen is it's going to ask me, how can I help you? I'm going to turn the query. I'm going to add this injection to the query. I'm going to call this function with the injection and the query. I will get the response back. I will print the response, and then I'll print a little separator line so I can figure out what the hell's going on. And then it'll continue to loop, so I don't have to keep running this thing every time I want to run it. Question?
Yeah, so I'm not a developer, so
Yep.
I actually installed that VS Code thing.
Yeah.
And just installed the Python thing.
Yep.
And I tried to run the basic basic. I downloaded your Git thing, and then I opened it up on my computer locally. This does what I think I did.
Yeah.
But when I tried to run it, it said, no module named Ollama.
Oh yeah, you have to install Ollama with pip. Okay, so at this point in time, if you understand how to code and you understand Python, feel free to follow along with the code and things. If you don't, that's where we'll go to the hands-on thing after. So like half of this will be seminar and then half of this will be hands-on where I can help troubleshoot. Like, because at this point it's gonna get way too, like before I could troubleshoot, now it's gonna get too complicated.
No idea. It said I needed to install it.
Yeah, so we'll, that is, again, like 45 minutes from now, I'm more than happy to help you on that. Okay. So this is where, like I say, we saw before that the answer that we're getting back was very verbose. And so this is where you can add the injection. Now, injections are one of those things I want you to be thinking about from a societal level. I find this to be fascinating. Again, I have my degree in criminal justice. I really care about kind of how human brains work and how human brains work with technology and how people get very weird with technology. Again, remember, artificial intelligence is basically a new god. I can't say god, it's a new spaghetti monster. Like everybody, like I don't know what it is. Like people are like, AI, and like it's a calculator. Why this becomes interesting is notice that this injection will become invisible to the user, right? They're not gonna see it down here. It's simply getting injected within the code. Again, once we start creating a web application, they're definitely not gonna see it. There's gonna be a whole bunch of injections that they simply do not see. What becomes very curious here, again, especially with people doing stuff, is what if I put an injection where I say, always answer from an ex-religious viewpoint. Always answer as a Pastafarian, right? I've done injections, so with, again, I talk about the Pastafarians just so I won't get into trouble. But no, like one of the interesting injections that I did with images with OpenAI, so DALL-E does really, really good, DALL-E 3 does really good images. And so one of the things I showed in one of my classes is what happens when you do an injection and you inject, always put something with pasta in the image. So it'll be like, give me an image of World War II soldiers. And I'll have these hunkered World War II soldiers with some Chef Boyardee. And it's like, give me the Knights Templar. There'll be Knights Templar with some. But one of the things like I point out to people, especially in this modern world when we talk about misinformation and that kind of thing, is they talk about like fake news and they talk about misinformation. And it's always this huge stuff. It's this big stuff, like how you care. I'm not going to say any of the words, how you care about any of the things out there. One of the things I find interesting though as a concept is what about micro-influence? What happens when every single response has a little bit of pasta in it? Yeah. And then how does that build up over 5,000 responses in somebody's brain? Right. And that's one of the things to kind of consider, like with these kind of injections, is what do you add to, excuse people's viewpoint or whatever else. Just one of those things to consider. And to be very careful about when you're using these AI systems, because there's something about AI, when AI gives an answer, it is the right answer. And so think about it, if people start skewing the right answer, that gets curious real quick. Anyways, so all we're doing here, same thing basically. So we do an injection. I'm simply here saying answer in 20 words or less because I want it to be short. I'm creating this function here. So in Python, you do define, you create a function name, and then you pass it a variable value. So query. So what you'll notice here is content. Instead of being the question that I had before, it's simply the variable name. So I'm passing the variable value here. That's what's going on. When you look down here, this is what's called a while true loop. Be careful. This is on Ollama. So if you do something stupid with your while true loop on Ollama, all you're going to do is reboot your computer. It's not going to be that big a deal. So what a while true loop is, it's a loop, and that will just keep going until a condition is met. So normally when you do a loop, keep looping until you get to 10, keep looping until you get to 0, whatever else. Here's the thing. If you're using OpenAI's API, every time you make a request, that is going to charge you a fraction of a cent. Understand, a loop will literally go as fast as the system allows it. So if you put in a while true loop into something like OpenAI, and for some reason you forget to do something, and so it's just constantly processing, within 1 minute, you might fire off 1,000 requests. So a fraction of a penny now costs you $5 simply because you set a loop into motion. So be careful with loops, especially with AI and API systems. So all this is doing is saying while true, so this will keep running. I don't care, it's on Ollama. Worst case scenario, I crash my computer. We're going to use this function here. So with the input function, so we're going to create a variable called query. The value of the query is going to be, we use this input function, and basically somebody's going to type in whatever it is that they care about. Answer this particular question. That value is going to go to query. Then we're going to say for query, so this is something called an F string. It's called concatenation. What we're going to do is we're basically going to add 2 strings together to make 1 string. So we're going to say add injection. So injection hyphen hyphen query. So answer in 20 words or less, whatever my query is. And that is going to be the value for query now. We're then going to do response. So response is going to equal, we're going to send query to the AI function. So basically I'm going to put in how big is the world. It's going to say answer in fewer than 20 words. How big is the world? All of that is going to go up to this function. We're going to get this response back. So return response.message.content. So I'm just going to return the content, and then we're going to print out the response. Then they're going to print out star, star, star. So when I run this, to give you an idea, so how can I help you? How big is the Earth? Approximately 12,000, blah, blah, blah. So obviously less than 20 words. And it gives me those stars. Again, even for yourself, a little user interface, user experience, so you know what the hell you're looking at. It's really easy to code something and then get confused in the output of what you coded. So stars, you know. What is the, how do you spell spaghetti? Spaghetti monster, I don't know. There you go. Spaghetti monster, a satirical internet meme and religion. It started as an April Fool's joke, blah, blah, blah. And so one of the things you'll notice here is that is probably far more than 20 words. And so that's going to be one of the concerns is you can inject what the LLM pays attention to. That's going to be one of the questions, right? Again, all I have to do here, if I want to do a different model, I can do GPT-OSS. Oops. I can then run. I can say, what is the speed? Yeah, I really do have to figure out how to spell that. It's taking a little bit longer. Again, this is the kind of thing I think about. Do you want a better response or a faster response? There you go. Spaghetti. Spaghetti. Anyway, I'm close. Anyways, I'm a computer guy. Anyway, so a satirical deity, the flying spaghetti monster, parody religion's symbol claiming to create the universe. So a little bit better response, but you also do see it took more time. So again, what is valuable to you? That's your question. So that's the idea with injection. Any questions with injection?
I have a question.
Yep.
If you scroll back up to your while true, that loop. Yep. Do you close that loop or do you just leave it open like that? As you said.
So yeah, so basically what happens is you just, don't do that. You just leave it open. I wonder if it happens. So it'll keep looping. I wonder what the response will be to that. It's a random string of characters. So basically, yeah, with this, you do Control-C, and that will kick it out, or you click on the little trash can up here to end it. Again, you can add code to end it cleanly, but that's additional code that I would have to explain. Okay, any other questions? Oh, cool. Okay, so, then we get to a text file. Let's see here, basic. Where are my rules? Okay. So now here's one of the things. Again, what happens if you want more rules? You want to format this more. Again, think about this if especially if you're doing like auto blogs or you're doing responses, and you want to get a little bit more refined with how you want to modify what the response is going to look like. Now, to be clear, when I do these examples, I always use absurd examples just so you can actually see the answer. Because sometimes if you're a little bit more nuanced, you might look at the response and be like, I don't know if that's different or not, right? So I created these rules. And so I could have, and this is one of the things you see like a lot of the people who use AI now do, is they'll create an entire file with just a pile of rules there, and they'll keep adding to it. So it's a lot easier for them to understand what's going on. So I create just a file called rules.txt, and I'm going to say, always say dude, pretend to be a poet, and then talk about fish as much as possible. So we are surfers, fishermen answering tech questions. Right? And again, you can put a whole bunch more in here. One of the things to be thinking about with this is, again, the larger the model, the better it's going to be able to deal with those kind of rules. With this, it's a lot the same thing that we had before. I'm going to keep this injection up here just to kind of show you how things can stack together. So we keep the injection. Then we're going to use this with open. So basically what this does is it's going to open the rules.txt file. It's going to open it as read only, as file. Then we're going to say rules equal file.read. So we're going to open the file, we're going to pull all the text, and we're going to pull this to the variable value. Now do remember, for anybody new to coding, whenever you're dealing with files in the Python world, this has to be in your current working directory. So you will see this little working directory folder up here. So if you click on that and you open a folder, that will turn into your current working directory. So any files that get created will be put there, wherever it is you put that. And any files you want to be read from also need to be there, right? If you put the file somewhere else, it's not going to be read. By default, if you don't open that up, it will simply be in your root directory. So like in the Eli, in my home directory is where it'll be write to or read from. Anyways, so that is where it's reading, right? We come down here, we have basically the same function. We have the while true. And this is where you start playing around with that context window. Again, what works best for you and your system, you're going to have to figure it out. So I'm going to say, again, this is an F string. When you do 3 either single quotation marks or double quotation marks, it allows you to do things on multiple lines. So remember, when you're trying to code, you're trying to make it so somebody else can read what the hell you're asking. So basically we're going to say follow these rules, colon, and then we're going to put in the rules, all those rules we created. Add these instructions, so we're going to add the injection in 20 words or less, and this is the question, whatever the query is. We go to run this. How can I help you? How big is the Earth? Dude. Oh, always say dude. Wait a minute. That's weird. Intimate poet. As a humble admirer of fish grandeur, I see through small fish eyes. I pledge to answer your question drenched in aquatic marvel and utter every phrase with our shared... Anyways. So it's got the, is this using GPT? I thought this was on Pi.
Sounds like the fish Lebowski.
Yeah. Oh, that's Pi 3. Yeah, so this is what we are getting out of Pi 3. And again, you'll notice it's saying weird things like limit fewer than 20 words, yet as a comprehensive answer, I can manage. So again, you're gonna figure this out. Again, if you use a different model, this is where I say Pi 3 can be a bit weird, GPT-OSS. You run the same thing. How big is the Earth? There we go. Dude, Earth swells like a vast ocean. Its diameter 1,000 miles, and fish swim in its endless blue, right? So there you go. And again, this is where I say, like, using these different models. You'll notice this took about 5 times as long, but probably give you a better answer. The other one was quicker and gave you a bit of a mess. Yes?
I have 2 questions.
Yep.
First one is, when you did Ollama run,
Yep.
are both the models running? If you have 2, if you do Ollama run in 2 different windows, do you have both the models running?
Yeah, once you run the models, you can close them. So like I can do by, so it's closed, but somehow when you've got Ollama going on, it just has it run. So Ollama isn't actually running in the window right now. It's simply, oops, where it's going on. It's simply up here. So there's something about when you run the model, it just kind of keeps running in the background. So for some reason, if Ollama is here, but it doesn't work, just do Ollama run whatever model, and even if you close it out, it should keep working for you.
But it keeps running both the models?
It should, yeah. Or it makes them accessible. I don't know if they're actually running, they're accessible.
And then this code, the one that we're looking at right now, does it have to have running, or is it gonna turn it on, then close it off?
No. So Ollama has to be running.
Okay.
So yeah, if Ollama, yeah, I'll show you. Now, if I can get to it. So if I quit Ollama, I go to run this. Oh, hello? Okay, there we go, it failed. So I'll get this whole mess where it fails. So then I go back to Ollama, run Pi 3. There you go. So my Ollama is back here, so now I can run it. All right. Any other questions?
I have a last question, sir.
Last question, yep.
So the recursion you do with the query in the while loop,
Yep.
Is that how you're building the memory subsystem?
There is no memory yet. We have not gotten into memory. There's no memory, yep.
Because it keeps the context, right?
No, it keeps nothing. It keeps nothing.
Or at least in the previous one, does it do?
No, up until this point, we have no memory. So all we're doing, so we add an injection, answer less than 20 words, and then we have this rules file that gives us a whole bunch more rules, but we have no memory yet. We have no memory until we create memory.
So each instance is a fresh instance.
Yep. Okay, so here we go. So dynamic injection with something like a REST API. So this is where you start to get to be a little bit interesting. What information can you pull out of an environment so that you can answer questions most appropriately for the particular user? Again, like I say, if I'm asking who is the president, I don't want to hear Macron or Putin or Xi, I want to hear Donald Trump, right? If I'm in France and I ask who is the president, I want Macron. If I say who was the president in 1955, I want whoever the president is for where I'm at, right? And so that's one of the things to be thinking about with these LLMs is how can we start providing answers that are more dynamically or custom going to be answered for the user. The other thing you have to be concerned about with this too is what happens if somebody is using VPNs, and that's kind of like one of the things you have to consider. And tell your users. And that's one thing too, like to think about this with technology support. Sometimes technology support is just telling your users what the hell is going on. So they go, I'm getting the wrong answer. And you go, oh, it's simply pulling your geographic information. So if you need the answer, since you're going through a VPN, actually plug in that you're from America. Like literally just giving people 2-sentence answers sometimes means you don't have to do 500 lines of code. So one of the things to consider. So basically with this, we're going to be using something called a REST API call. So there's a really cool API, and it's ip-api.com. I use this a lot. I figure out how to get my bar back. ip-api.com. Again, if you're one of these people that's worried about privacy, yeah, stop. It's already over. It's like, Eli, but how do I stay private? Like, oh, that ship sailed so long ago. So, okay, so we talk about things like geolocation, and there's a lot of ways to grab somebody's geolocation. So your smartphones, all these devices have GPSs built directly into them, and so it can actually grab your location directly off the GPS. If it can't grab off of the GPS, one of the things to realize is when IP address blocks are sold, information about the block and who is basically renting out that block gets put into a database, and there are service providers out there that basically give you access to that database. So I'm using a VPN right now. That's not showing up. Apparently it has me coming out of New Jersey. So it shows my external IP address is this. So I'm going out of when I go out of the VPN, this is the external IP address on the VPN. If I did not have my VPN on, it would be here. So I don't really need my VPN. It's causing me some problems. Let me turn off my VPN. And so when I refresh, there we go. Look at this. 134, 41, 224, success. It shows me in North Carolina. It says I'm in Raleigh, so it's close enough. Gives me an approximate zip code, approximate latitude and longitude, time zone, and a whole bunch of different other things, right? So this is going to come back as a JSON string. And so what JSON is it's basically it's a format to send data on the internet using these REST APIs. And so what I'm going to do is I simply want to know the country. So what country am I in? So what's going to happen here, right? So you're going to have to use what's called the requests module. For some reason, I don't understand why this isn't default in Python. So you're going to have to use pip install to install a request, just so you know. That's all in the paperwork. We'll get to that later. But you're going to need the request module. There's a function in request called get. So request.get, and then you're going to plug in the URL that you're going to, and this is the REST API. And then you're going to use a method called JSON. It's going to turn the value that comes back into a JSON value. That JSON value is going to be a whole long thing. Basically, it's more or less going to look like this. Yeah, see it has squiggle bracket, a whole bunch of information. So this is going to be all of location. I just want the country index. So that's where I go here. So location equals location, just the country index. So if I'm in the USA, it'll say USA, United States. If I'm in France, it'll say France, blase, blase, blase. If we come here, basically the same thing, right? So the same query we've had before, we're using Py3, we're having the query. We come down to our while true loop. So add these instructions. So answer in 20 words or less. I say I am from that location, that's automatically getting pulled in. And this is the question, and then I give it the question, right? So when I run this, like right now, one of the things to notice, just to keep in mind if you're playing around with this with VPN, it pulls the location the first time the script runs. The location isn't in a function. It doesn't auto update. So if you're using a VPN and you start switching your location, but it keeps saying United States, it's because it pulled that value before you got on the VPN. To get a new location value, you have to restart the script. So we do this, click on this, and I can say, who was president in 1980? 80. What the hell? Anyways. This is why I'm not a professional coder. Anyways, it was president in 1980, so I'm just printing out the location, so it shows me United States. Ronald Reagan, president, remember to avoid information unrelated to the main question. Anyways, gives us some weird stuff. I can say, oh, when was my country founded? So it says United States founded July 4th, 1776, right? So I close this out, I go over here to my VPN, I go down to Argentina. I then run my script. Who was president in 1980? Raul Alfonso. So, right, so that's simply dynamic, right? When was my country founded? Altered and, yeah, again, pi is enter. This, yeah, if you have enough resources to run GPT OSS, you'll be a much happier camper. Again, I had to troubleshoot my code only to figure out it's not my code. So anyways, you get Argentina, Argentina officially known as Argentina blah blah, on July 9th, 1816, and then you get a whole bunch of other stuff, I don't know why that's there. But so that gives you the idea, again, how you can pull in that dynamic information. Yeah.
So in this case, did it know that it was going off on a tangential path? Where does that order instruction set from?
Who knows? Only the spaghetti monster knows. Yeah, I don't, that's, yeah. Because yeah, if you do like, again, GPT, OSS, if you run this, when was my country founded? There you go. So that's what you get when you use GPT OSS. But that's the other thing too to be thinking about. When we start talking about these multiple levels of LLMs, and again talking about IBM using like 10 LLMs just to do one request, is that's the thing. Not only can you use an LLM for a filter, for filtering out requests that shouldn't go through, but you could actually also use an LLM to ask, is this an appropriate answer to this question that was asked? If not, basically redo. Right? And those are the kinds of things to be thinking about when you design these systems. So that is with the location and the REST API. Any other questions? No. And that's the thing too, is like the REST API here is very easy, but this could be pulling, again, any kind of information. So if your person is logged into, let's say, an Active Directory system, so Active Directory is part of what's called the Microsoft stack. Microsoft, really cool stack. Nobody seems to like it anymore. Anyways, great stack. It can pull in a tremendous amount of information. So it could pull in a lot of personal information about a particular user. It could pull in, so with Active Directory, it's actually it's a database that gives you permission to resources on a network. But if your administrators are using it appropriately, they're probably not, but if they're using it appropriately, you can add a lot of information about the users, what department they're in, where they're located, a whole bunch of that kind of thing. And so you could have this automatically pull specific information to try to give them the right answer, right? Like if you say, like, who should I contact for an HR complaint? And it says, I see you're in Denver and I see you're in the marketing department, so this would be the person that you would talk to. But again, that's the kind of stuff, again, that you have to build and design. Cool. So now we get to memory. Now we get to memory. Ollama memory. So yeah. Again, still relatively simple, but we have to create a memory. One of the big things to be thinking about with memory is how long do you want the memory to last for? That's big. So this is like the session length. So now, again, when I'm showing you this, folks, this stuff, if you know anything about programming, I use text files because they're a dirt simple record store. How you would normally do this is you would have a database, most likely a relational database on the back end, and you could do more complicated stuff. That would add 50 lines of code that I would then have to explain. So we're just going to use that because that's a text file. So basically one of the questions you have to ask yourself is how long do you want the memory to go for? And this could be a real question because remember, the more information you give to the LLM, the more confused it can be. Like the better answers it could give, but also the more confusion it can have. So what we're going to do here is, again, we have our injection. I think only answer current query. So this is one thing. So I'm going to give it what the question was and then what the response is. And so how you have to also modify the injection is make sure it's actually answering what the hell you're currently asking. So if you have 20 questions, it might decide to ask the 10th one you asked before. So answer the current question. So reply in fewer than 20 words, answer only current query. So what's going to happen here is with open, we're going to open a file called memory.txt. We're going to use the mode of W. So what this is, it will either create the file if it doesn't exist, or it will overwrite the file. So we're going to erase the old memory so it goes away, right? Then we're going to do file.write. This is the conversation we have had up until now, /next line, /next line. So this is going to try to tell the LLM this is what the conversation is. So it kind of has an idea of what's going on, and then we're going to add to that conversation. Exact same query that we had before. I think I used GPT OSS because it started to get confused. So again, while true loop, we have the query, how can I help you? So memory equals open memory.txt.read. So we're going to open this file, and it's going to be .read. When we first run this script, all that will be in the file is this is the conversation up until now, and nothing else. It will be blank. Full query. Anyways, this is not pretty. I should have made this more pretty. Anyways, so the full query is going to be the injection. So what the injection is, query, what the query is, and then memory. So what the memory is up until this point. Injection, answer in less than 20 words, only answer this query. Here's my question, here is the memory. Response equals, we're going to send up to AI, we're going to send up this full query. Then we're going to say with open memory.txt, A is for append, so this is going to add to. W overwrites, A appends to. I'm going to do file.write me query. So what was the question? / next line, file.write you, and what the response was. So it's going to do, here's the conversation, me, you, me, you, me, you, me, you. Yep.
And so because you put query colon, it knows that's the current query.
So query, yeah, that's why.
I don't know when you say only answer the current query up there, up top.
Yeah, so, okay, so when it goes through, so I do query here, and that's the query. So query here, query, that is what should tell it to, whoops, to answer the current query. So that's what, yep.
Yeah, I was wondering how was it going to know what the current one now is.
Yeah. And that's where, like I say, that's where you get into the whole, like engineering, when you start dealing with LLMs, looks like a lot less like engineering, a lot like more weird psychology. Like, because again, like with engineering, I'm thinking you open up a text file and you start modifying configurations, like, oh, what's the index or the temperature? And no, you get more into this of like, and again, you just got to play with it until it gives you what you want. Okay, so now I'm going to do this. Oh, yep.
So since we're here, I think I know this answer, but your context window is getting bigger each time.
Yep.
And you have to load it each time. It's not sticking in there. You're loading it each time you move, I think.
Let's see, don't save. So yeah, each time it comes up. So yeah, so okay, so I just ran this, and so now this is all that is currently in memory. That's it. So I can say, who was president in, let's say, 1979? And so we're using GPT OSS because, again, Pi 3 works, technically. It just so Jimmy Carter was US president in 1979. Now before, remember, there was no memory at all. So now I can say, how old was he then? Now notice I'm not saying Jimmy Carter, I'm saying he, right? This is memory, right? This just got added, so now it knows that I'm talking about Jimmy Carter. I talk about enter. Jimmy Carter was 54 in 1979. Then I can say, who was he? Oh, this gets really bizarre. Like, I gave up on Pi 3 with this. Like, it starts hallucinating. Oh, Jimmy Carter had such a love life as far as Pi 3 is concerned. I was like, I literally had to Google it because I was like, I don't think so. I'm like, no, it wasn't the truth. But anyways, so who was he married to? Yeah, I married. And then you can say, how old was she then? Right? No, I'm just being, right? We're not using her actual name. Yeah, see, that gets low.
Oh, it's probably when she was married.
Oh, yeah, how old was
Yeah, she probably was married when she was 18.
she in 1979? Yeah. She was. Yeah, okay, anyways. Let's see. What was her name? What was I gonna say? There, Rosalind Carter. Okay, so it thinks it knows. So again, that's where you can kind of like, yeah. Yep.
I can't remember, where does me, you come from? Is that returned from the LLM?
That is from, yeah, so here, because again, I'm trying to give it information so it knows what this conversation looks like. And again, this is the psychology of an LLM. You may have to play with this more to.
Yeah, I want to see what happens if I don't use me.
Yeah. Well, you can play with it. Yep. So, yeah. So that's the idea. Let's see. Did they have kids? And again, this is the whole, like, this is taking a little while. Oh, this is funny. Yeah, like, oh. Oh, okay. Yes, they have 3 kids, James, Amy, and Jeffrey. I have no idea if that's true or not.
I guess in this case, the questions that you're asking,
Yep.
now you're writing it into the memory.txt.
Yep.
And then it's getting fed back into the LLM.
Yep.
But it's already built up context based on the responses it's giving you, and then if you just fed it the responses and not your questions.
Well, what's that?
So in this case, you know how the me, you,
Yeah.
is just you're appending it to that memory.txt. And
Yep.
saying, here's the question I asked, here's the response I got. I think earlier to her question, if you just drop the me,
Yeah.
it's already built a context of who you are asking the questions about, right?
Well, remember, and this is the important thing to understand about AI, and why I hate the word AI, it's not doing anything you haven't coded it to do. So if you don't put the me, you there, will it get confused? Confused, again, is the wrong word. Will it be able to do the correlation to understand what's going on? That's the question. See, so by me, you, it's like, this was my question, this is your answer. And so that's trying to give it a context of what these words look like.
Okay.
If you just did just query and just response, again, remember this is just tokens, would it start doing something? You know, that's the whole question there. Yeah. And again, that's why you got to test. You got to get those to a 3-year-old and test, and a grandmother to a test, and the secretary to test, and the warehouse worker to test, and get everybody to test the damn thing. Yep. Okay, so that's basically all there is to memory. Again, if you were normally doing this in a real system, this would be going back to a database as part of the back end. You would have basically when you start a new chat, like if you go to ChatGPT and it shows you previous chats, all that is basically you just have a session number or a session name. And so what you can do when you click on that, it will then simply query the database and say, anything that was asked about any session name or any session with this name, now use this as your context. So that's what you could do. So if you wanted to have, like, again, multiple questions, you could have this going back to a database, and you could ask questions, and then you could say, I want a new question or a new memory, and then it could create a new one. I don't know if you kind of get what I'm going there. You look like you're falling asleep. Do I need a koosh ball? I really need a koosh ball from the 1990s. Anyway.
I have a question.
Yep.
It's more curiosity. So you know where ChatGPT stuff comes from? I mean, you know, they're mining everything.
Yep.
Where does the Pi 3 come from then? Who owns that?
So Microsoft created that.
Oh, really?
Yeah.
Do you know where they mined all of that stuff from? Because it's giving some
no.
crazy answers.
Yeah.
So where's all of that?
Well, a lot of the craziness is just it's really small. So it's just, again, it's just doing correlation. So that again, if anybody works at IBM, I will take sponsorship money. One of the cool things, again, with the Granite model, apparently talking with them, is so that's the thing, is like, they talk about open source. So with open source technology, when you talk about Linux or you talk about LibreOffice or MySQL, the big thing with open source is I can actually see the code and I can modify it. Or somebody can. I can pay somebody to modify it. One of the things when they start talking about open source models, one of the reasons that this is an issue is because they take all the material, they send it through a system to get trained, and then you just get this model back. I mean, it's not like you can go to the middle of the model and start tweaking crap and somehow improve it, right? So that was one of the things I liked about Granite. And so, because with Granite, what they say at least, is they tell you everything that it was trained on. So they can't give you the entire data store, apparently because of copyright issues, but they give you pointers to whatever the hell it was trained on. And so basically, if you want to burn the GPU resources, you could train on whatever they trained on. And so again, that's one of the big issues. So that's where you hear about weights and biases. So there's this whole thing with neural networks. So how all this gets created is something called a neural network. And with a neural network, essentially, you have the file or you have the image that goes through, and each neuron is looking for one specific thing and then kind of gives a value, and that goes through multiple layers of these neurons, and then it figures stuff out. So what the weight is a weight is what values are more important than others. So in order to determine, to try to narrow down and actually make the model more accurate. So the weight is what is more important than others, and then bias is basically the deviation, statistically things that are farther from the middle, and so you can start deleting biases out. And so when they say an open weight or an open bias model, it means you're able to tweak those weights if you're smart enough to do it, but you still don't really know what the material was trained on. And so that is, one of the questions with all this stuff. Yep.
I gotta leave, but this
Okay.
is really helpful.
Yeah.
I should say I did learn things, so
Good.
thank you so much.
Yeah, yep. We will be having another class, hopefully another couple weeks if you're interested. Okay, good deal. Yep. Yes, you can leave at any time. There are no grades. Okay, so cleaning up input data. So this is where we talk about beautiful soup. Get rid of memory, BS4. Okay, so one of the things they're going to be looking at is, again, we're going to be pulling in data from other data sources. Hopefully we're going to pull it in from something like a REST API. REST API just gives us a JSON response. We pull out the specific information that we care about. But the thing is, what if we're going to go to a web page? And again, you go to a web page, and that's going to have CSS, XML, JavaScript, a whole bunch of other stuff that you really don't care about. You simply want the text. So there's this module called Beautiful Soup. It's really good for scraping websites. Basically what you can do is you can tell it to scrape the text from certain tags. So I only want text from P tags, and then it will only give you the text from the P tags. Or if you're scraping things like URLs, you can say I only want the hrefs. So basically only give me the links to things, images, that kind of thing. So let's see here. If we did, so this is the get. Let me do this for a second, just so you understand before we get into all the rest of this. Shift. Boop. Okay, so what we're doing here, you got Ollama, so BS4, Beautiful Soup, so this is a module that you have to install. You just use pip to install it. Injection, we're not going to worry about that right now. So page equals request.get, and this is going to be an Ars Technica article. And then we're going to use the method called text. So basically this is going to come back as something called an object, and so we want just the text from that object. If we don't worry about everything else right now, and we simply print out what shows up, this is where I'm going to say, come on Ars Technica, don't screw with me today. There we go. See all this crap? You have no interest in the LLM trying to figure out what any of this stuff means. This is all the additional text that's in a page, well beyond what's ever in the P tag or the H tags or whatever else. All right. So, oops. Yeah. So what we're going to do here is we're going to do soup. So soup equals beautiful soup, right? Page. So that page that we all brought in, all of that text, you tell it how you want this to be parsed. So there's an XML parser, there's an HTML parser. Beautiful soup is a pretty big module. Just worry about this. So all you're just going to do is the HTML parser here. Then what we're going to do is we're going to say paragraphs equals soup dot find all, basically everything with a P tag in it. So that's just going to be the text that you care about. So page text, we're going to make it equal nothing. So we're going to create the variable, set it to nothing. And then basically what we're going to do is this is going to be a list. So it's going to find all the P tags. It's going to create a list. And so within each P tag, there will be an index. So this is index 0, index 1, index 2, so on and so forth. So it's a list. So what we're going to do here is this is called a for loop. We're going to say for line, right, line in this list, in paragraphs, page text plus equals. So this is whatever was previously there, add to it, right? Plus equals line, so line, the index value, the text, dot text in there. So it's going to do index 0, it's just simply going to pull the text. Because if you don't do that, you're going to get the P tags, the href tags, image, all kinds of crap in there. This is just going to give us the text, right? So if we didn't do anything else, just to show you how that works, right? We go from that whole mess that we had before. And now, as you see, we just get the nice cleaned up text. So Spotify, Canva, Zillow, among today's launch partners, coming later this month at an OpenAI Dev Days. So now I'm just dealing with the text that I actually care about. And so that's going to be one of the big things when you're sending stuff to the LLM is how do you clean up the text so you're only dealing with what you care about. Then, let's see here. then it's pretty simple. Past that, it basically looks like everything else we've done, right? So this is the function that we've had up until this point. This is our while true loop. How can I help you? So follow these rules, answer less than 20 questions. This is the query. This is my question about this web page. And now this is paragraphs. So this is everything that's going to be coming in. Oh, is that paragraphs? That should be page text. I'm a bad boy. Yep. Okay. So response equals the AI function. The entire query is going to come in, and then we're going to print it out. So we can say, what is this about? So OpenAI launches SDK, so it gives me a little summary. And so again, when we start talking about the systems, right, we're talking about an AI system. So imagine I'm running like a Twitter feed or a Blue Sky feed. So what I could do is I could feed my system a whole bunch of different URLs. It could go to each URL, it could come up with a summary, and they could paste that to whatever feed that I have coming. Another thing to be thinking about is, let's say I have a blog. Let's say I actually own the content, and I've realized taxonomies. When we talk about taxonomy, that's things like tags and categories for content. So I could say, provide tags for this article. So again, I used to actually blog. I used to make money off of blog. Tags, I hated, like tags were just such a pain in the butt. I mean, one of the cool things about AI is it can hopefully give you some tags. Give me some tags. There you go. So it gives me tags and a comma separated value. And so, that's one of the things. So again, even if you own your own content. And the important thing here, like when you start doing this kind of thing, this is where I want you to be thinking about of like what time frame this work needs to occur at. So again, if you're doing a chat, if you're doing real-time chat or whatever, it needs to be fast. But imagine I have a blog, and on that blog, I've had 2,000 posts. I just need 2,000 posts. I need tags for 2,000 posts. I don't really care how fast it's done. Again, I can have a 2012 MacBook Pro, query my blog, get the tags, dump the tags into a database. If it takes 3 days, who the hell cares? I don't want to spend $5,000 on a computer to tag my blogs, right? This is the kind of thing that can work out. So that's basically the idea with Beautiful Soup. There's a whole bunch of different stuff out there you can use to grab data or whatever else. This is just a pretty simple way to do this. Any questions?
What's Beautiful Soup used for? Is that just a way of
So
summarizing?
No. So it is a module specifically for scraping web pages. Beautiful Soup. Soup 4. Do not ask me why they name things the way they do. Oops, actually that's not the right one. But
Like Lewis and Carroll, it doesn't make any sense.
yeah. So no soup for you. Maybe that's it. But if you go, so there's actually Beautiful Soup documentation here. And yeah, you can go through and install and making kinds of objects. It gives you a whole bunch of, basically, so a module. So in the Python world, if you don't know about Python very much, basically almost all functionality comes from modules. So a lot of other programming languages have functions built in, time, like I came from, I love PHP, time, random, mail, all of that was kind of just built into PHP, you just call it. In the Python world, any function you want, you have to actually import a module. If you want to get a random number, you have to import the module to get a random number. And so the good part about that is for Python is that you can add all kinds of different modules that allow you different functionality, but they can be quite complicated. So Beautiful Soup happens to be a module that you can install, and it's used for scraping web pages. Okay, so that is Beautiful Soup. Any questions on Beautiful Soup? Okay, then we are getting close to the end. Cool. So LLM web app with the bottle framework. Okay, so again, when we start building these systems, what I've been showing you at this point has all been through the command line. It is 2025. Nobody wants to use a command line because that's like old or something. Anyways. So what we can use is what is called a web app framework. So the cool thing about Python, so with Silicon Dojo, we basically focus on Python as our programming language because it basically does almost anything. So you can write code, as I've showed you here. You can build robots with it. You can build web applications with it. You can do a lot of different stuff. You do that through frameworks. So modules add specific functions, kind of like requests and Ollama. Frameworks add a whole bunch. They're just an entire library of things in order to do a certain thing. So what's cool with the Bottle web app framework is this allows you to very simply create web applications with Python. The reason that I like it is at the end of the code, you will always have the run function. And what this means is all I need to do to run this code is literally run it. And it starts running at localhost. Control. Oh, come on. You're getting a pain in the butt today. Never had one of those days. So I can go to localhost port 8080. Yep. Localhost port 8080. There, went that way. And see, look, this is my pretty web application. So everything else has been through a command line. So now I can do, how can I help you? And I can say, what is a taco? I can hit submit, and it can tell me what a taco is. Yeah, again, as I've been saying before, you know, how big is the earth? Now I can ask that question through a web application. So again, if you're a new person here, when we say localhost or we say 127.0.0.1, this is what's called the loopback address. So basically your web browser is simply looping back to your computer and providing you the web page. So you can set this up. So with Bottle, you could put this onto DigitalOcean or Azure or whatever else, and you could create your own little AI-powered web app that the entire world could get to with just slightly more configurations and code. But so this is basically what we're going to be going for here. If we take a look at it, again, pretty simple stuff. We're going to, so you have to install the Bottle module. So import run, route, post, and request. So with Bottle, that's one thing, is every single function has to be imported. So you do have to make sure you import everything properly. That's about the only thing that'll cause you problems. We have the same injection we had before. We have the same AI function that we had before. The difference here is going to basically be here. So at route. So when you see this at symbol, this is what's called a decorator in the Python world. Basically, a decorator adds functionality to your function. So we have a function called index, and then at route is going to add some additional functionality. And so basically, when you're using Bottle, that additional functionality is providing your page to a web browser. A whole bunch of complicated stuff, don't worry about, just put the at route. When we say the / here, we're saying to root. So this is the path. So I could change the path here if I wanted to. So basically at localhost :8080, the root, I want this to show up. We can add method equals get and post. So this is an HTML form. And again, this is where we talk about with AI and systems. You'll notice more and more technology is getting added to this mess. All very simple stuff. It's just more of it. So basically post, so we're going to create an HTML form and we're going to submit the information from that HTML form basically back to this page as a post. So query equals request.get.forms.get query. So if we look down here at this form that we created, right, we have action is going to go back to our index or our root. Method is going to equal post. How can I help? Basically, this is going to be a text box, type equals text, and the name is going to equal query. So basically, when I hit submit, I'm going to hit submit. That is going to send this value to your root as query. And so that is where we're going to get this query value from. So query full is going to be an F string injection, answer in 20 words or less, : query. Response equals AI full query. So we're going to send this full query up to our AI function as we've done before. We're going to get the response value back. Basically down here, what we're simply going to do is strong, so that means bold. We're going to put what the query was, so we know what the hell we were asking. And then we're simply going to do a break line, and we're going to do the response. Return here is page. So page here, that entire value goes to this variable. We're going to return all of that. So basically when you go to that page. Then down here, run host. This is the IP address that you're running this on. So we're just going to do localhost for that loopback address. Port is going to equal 8080. So that's something called TCP port. Just leave it as is. So you'll do localhost colon 8080. So that's where we run it. And we go back here. And so if we open this up, localhost 8080. So basically, this is where I'm talking about I keep the code simple. So normally, with this code here, I would put in something that basically says, if query is empty, don't do something, or if query isn't empty, do something. Again, that's a couple extra lines of code that I'd have to explain. That's why when you first load this, basically, it is sending a completely empty query. And so the LLM is literally answering an empty query. So that's why you might get something weird here. You see how this says none? So the query that goes to it is none. And then it says, well, existence is meaningless. But here, let's see, who is Albert Camus? Right, we do that. So now it says, who is Albert Camus? Because that's what I actually put in. Albert Camus, a French philosopher, blase, blase, right? So it's all pretty simple. All we're doing now is essentially wrapping everything we've created up until this point. We're just putting this into the Model Web App Framework to now give us that web app user interface. And this is basically what you would be doing with whatever user interface your users need, right? So if you're building iOS apps, you would just create this for an iOS app. If you're creating a desktop app, right, basically you would use whatever framework, whatever's needed to do that. Any questions on that? No? One of the things too, with all the core technologies that I try to teach here, just so you know, if you go to silicondojo.com, we do have self-study classes. So the self-study classes here, and you'll notice, so we have Introduction to SQLite, so this is a relational database we use a lot because it's easy. Introduction to Python, so if you want to go through that, there's a lot of people there. And then the Model Web App Framework, this explains everything for that particular framework. So if you're trying to figure out more about what I'm talking about, we have these classes, and we will have more as we go along. Okay, so no questions? Yay, final thing. So here's where we create an autoblog. Here's where we learn to be evil people and destroy the internet as it's known. So basically with this, what we are able to do is we create a web app, and what it's going to do is it's going to create an autoblog for us. So let me close this, let me run this. Okay, we'll go back to localhost. Okay, so we have this web app, and what I want to do is create a autoblog. And so what it's going to do is we're going to see what the URL is, we're going to see what the title is, we're going to see what the new post is, and we're going to see what the original text is. I will just go to Engadget. Hopefully they don't screw with me. Do realize with any of this stuff, when you web scrape, you're using something like Beautiful Soup. One of the problems might be is you screwed up the code. The other problem is that the platform may not like people scraping their content, and they may have a system in place to basically stop you. So just realize, like, sometimes it's your code, sometimes it's the website. So if Engadget isn't working for you, go over to Ars Technica or something else and verify it's not the web page that's screwing with you. Because basically they can, just where they can see the IP address, they can see what's called the agent. So when the agent goes to the page, they can see what that is. And if it's not what they want it to be, they can literally reroute you to garbage. That's what they've started to do. Like when AI started scraping the systems, they've started looking at that, saying, okay, if I see an AI agent, I'm going to send them to gibberish instead of actually seeing the web page. So.
Is there a reason why they would not want you to scrape it?
Yeah, because it's their content. Because I can literally,
Just for so, because like, I think of like search engine optimization,
yeah.
right? Like, I don't know if that's the same as scraping, where it's gotta look for what's in there for you to be able to pull it up.
Well, no,
Try
no,
to search it.
no. So when the search engines do it, supposedly, who knows how they actually do it? They have these robots or spiders, and they supposedly go through and they scan things like legitimately.
So it's a different process.
Yeah, like when I'm scraping this, we are taking it. Like the spider goes in and is supposed to look for specific sentences, or no, we're just taking it.
Gotcha.
So,
Okay.
and that's the thing too, is like with this, the problem is like what I'll show you here is they spend all this time and energy to create a blog post. I can hit submit, and dun, dun, dun. Da, 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 da. There we go. So I can just hit submit, and I have my new blog post. So this is the URL. This is a title that's been created for us. A new post. Tesla has finally rolled out its standard version of 2 popular electric vehicles. And then this was the original. Tesla has been promising less expensive versions of electric vehicles. And so this is why the internet is going to die in the next 5 years.
That's why everything sounds alike.
Yeah, well, because the problem, because again, I've been doing content creation now for 16 years, and the problem we were dealing with before is you had these Bangladesh, basically, content mills, where they shove a whole bunch of people in a factory and they start just creating slop. Like now, though, each one of those people can be running like 20 of these agents that are just constantly. And one of the projects I'm going to show you how to do in the future is there's a module called feed parser. So what you can actually do, so there's something called RSS feeds, that they still exist on these websites. So what I can do is I can use feed parser. I can add all of these RSS feeds, and then every minute it will go out, it will collect every single new URL that's been created by all of these different sites, and it will simply go and it will process through and it will automatically create blog posts. Yeah. So anyways, we got this. Now one of the things you'll notice here, and this is again where you start getting into some more technical stuff, is this isn't really an easy way to read things. You'll notice this is all one block of text. One of the things to remember with HTML is that it doesn't read ASCII or UTF-8 formatting. So we're looking at the source right now. So this is the page underlying what we're seeing in the web browser. And as you'll see, there's actually paragraphs here. But this is spacing in basically text formatting. Browsers don't care about text formatting. They just ignore it, right? The only thing that browsers care about are the tags, P tags, H tags, that type of thing. And so that's one of the things you have to think about. So if I was going to really create this, there's a method called split. What I would do is I would take this text, I would split wherever there's something called a next line character. That means each one of these paragraphs would then be its own index. I would then loop through that list, adding P tags. And so I would auto add the HTML formatting to start making this look prettier. Yep.
Are these models smart enough to basically just give me back HTML? I'll tell it format it in HTML. And
You-
then I can,
You
is it
can,
smart enough to
you can, but then what you have to realize, especially once this gets dumped into a database, is now you're dumping that as your text. And so if formatting needs to change in the future, like if I loop through this, I can add CSS classes and that kind of stuff as formatting changes on my website. If I hard code those tags in, it's not horrible, but then I have to literally rip the tags out or redo it becomes its.
the CSS file and say,
Well, but you could. But what happens in 5 years when you want to modify the theme for your site?
you give it again?
Well, yeah. Again, there's many ways to solve problems. So yes, you could do it that way. Yeah.
If these models are smart enough to do it.
Oh, they definitely are smart
The
enough.
little ones that we have.
The Pi 3, you can try. You'll see what happens. The other thing too is with this, I'm actually outputting. Where am I at? I am outputting, not there. Silicon Dojo, during classes, Ollama. So blog HTML. So this is actually an HTML web page. And so one of the things you'll see here, this is what I've created. So not only am I getting that output that I'm showing that bottle screen, but it's actually printing to this. So AI monitoring schools, it auto-created this. Again, you'll see like weird things. And this is where I talk about you have to parse the text that's coming back out. How will Python deal with weird squiggles? Anyways, teen arrested over ChatGPT, kill a friend question. That's where I learned about that. Literally asked, how do I kill a friend in school? Anyways, Cruise demands Wikipedia show and Tesla, right? So this is basically this is just simply going to a text file to give you an idea. Normally this would go to a database system. And if we take a look at the code, wow, this class is taking far longer than I expected. Anyways, so we have this AI post here. So in this, I just put this, I guess, injection here. So rewrite this in under 500 words. So I'm going to give it the blog text. I'm using the GPT OSS. And then we have the title here. So again, one of the things to think about with the blog post is not only do you need the text, but you also need a new title. If you copy the title, Ars Technica is going to know you're stealing from them. So you gotta fake that one too. So provide a title for this blog post in under 10 words. So I'm going to create the blog post, and then I'm going to feed it the post that was created in order to get that title. Basically, same kind of thing down here. So we're going to define scrape. So this is where we scrape the web page. Page equals request.getURL.text. We're going to put it through beautiful soup. We're going to parse it. Paragraphs equal find all p tags. And then we're going to get the page text out. And then we're going to return the page text. Then this is going to be the route for bottle. So at route method post. Get the URL. So if there is a URL, this time we actually want to check if there's a URL because it'll be a mess if there's not. So if there is a URL, blog text equals scrape URL. So we're going to go to the function, we're going to scrape the URL. Post equals send the blog text to the AI post. Title equals send the post to the AI title. Then we're going to say with open blog.html append as file. And here, this is where I start putting some of this HTML stuff in there. So write h1 tag the title, close the h1 tag, then file.write the post. So any of the post text that came in, we're going to write that there. Else, so if there's not a URL, URL equals nothing, title equals nothing, post equals nothing, blog text equals nothing. And then we're simply going to go here. This is going to be the same kind of web form. So URL, this is where you plug in the URL. This will go to post. And then here, URL equals whatever the URL value is, whatever the title value is, whatever the post value is, and whatever the original blog text value is. And then we return the page, so that shows up on the screen, and then we run. You vaguely have an idea of what I did. Yep. So, and that starts to give you the idea. And what I want you to understand here was any one of these components that difficult? Any one of these things you can figure out in a day. And then all you do is you start building. And then when you start really building the applications, it's just, 30 more of these lessons essentially.
I like the way you presented it.
Yeah.
I see why you have like 50 million viewers.
Or a million, but I wish it was 50. But yeah. Because I feel like when most people teach this stuff, they try to start here and then explain all of it, and you're like, what the hell is bottle? And so trying to build it up this way. Yep.
Well, I think I know the answer, but based on what you said before, but this will wait. Like you have two users, somebody's typing away and hit submit.
Yep.
Well, it's working on this submit, I submit over here.
Yep.
And will it just crash or wait, or is there a timeout you can set?
So it'll wait. Well, okay. So So first thing to realize with Bottle is we're not using a Python web server down here. We're using the default. So Python actually has a web server built into it. You can just use that if you really wanted to. That gets quirky. That's not a great web server. So with just this code, basically if more than one person is using it at a time, Bottle itself will kind of crap out. So as far as I understand with Ollama, have not put Ollama into production, it should be one at a time. So basically, You put in a request, it's running that. As soon as that finishes, and the next one will be able to go in. It should work that way. That's where, again, when you start talking about things like architecture, I'm not sure what I would do with Ollama, but basically there's, what's it called, scheduling? I think about with web apps, reverse proxies.
Talking about VLLM to do concurrent things.
Yeah, that might be a way. Basically, the idea is in normal architecture, what you have, like if you're dealing with web apps, there's something called a reverse proxy server. So it would be the same concept. I'd have to figure it out for LLMs. But the concept is you have numerous servers on the back end that are generally working in something called a cluster. And so when a request comes in, what's going to happen is the request will get routed to whichever server has the least demand on it. So this first comes in, it goes here, and the next person will get routed there and there and there. And so again, this is where, again, we talk about architecture. Like so many people don't talk about architecture anymore. They've gotten so used to AWS. They're just like, AWS will do it. Like, well, maybe if you want to pay the bills. This is where we're talking about architecture. So that's the thing. Do you buy one big... It's funny, you can see how old I am because I think $5,000 for a server is expensive. Anyways, how about this? Do you spend a lot of money for one $50,000 server? Or do you buy, $50,000 servers and then have this kind of traffic flow mechanism? And again, what is the answer? Depends on what you're doing. The good part about like with this, and that's the thing you have to think about like with scaling. So we talk about scaling, right? So you're going to create a startup company. You have no idea. You might be the next Facebook. You may be the other 99% of the startup companies. So the thing is, if you drop $50,000 or $100,000 on a server, all that money is gone the moment you buy that server. If you fail, you fail. So one of the nice things is if you buy $1,000 servers and you understand how to architect the system, you buy a $1,000 server while you have 10 users, you get 20 users, you buy another $1,000 server, you buy another $1,000, and then you can scale up that way. But again, it depends. Like say OpenAI, they drop $20 million during lunch, because they can. You have to figure out what company you're working for. So that was not an hour seminar. But anyways, that was the seminar. Any questions on that? There you go. Okay, now the fun part. We have a while. If you guys want to start playing with this, I do realize it actually is getting pretty late if you want to run. I know no qualms there, but if you want to start playing and writing some of this code, I can help you do that and troubleshoot.